काय कुणाच माझं ऐक ऐक कालच केले की तयार कुणी होय झालं का चालू काय झालं? चालू झालं? चालू करायचं का? काय झालं? होय, झालं का?
दिसते मी दिसते का?
त्यांनी ती हे लावलं असेल सर.
Sinha sir, are you there? Sir? Sir? Hello? Sinha sir?
Yes, yes.
Okay, sir. Thank you. Some problem with the.
What is the problem? Is it all right?
Prepared.
Susma ji, please start.
Yeah. Starting in 2 minutes, sir.
Now the problem has been sorted out or not? मेरा आवाज जा रहा है?
कीर्तने मॅडम सर विचारतायत प्रॉब्लेम सॉल्व्ह झाला असेल तर सुरू करा.
Okay, sir. Okay.
I am waiting for.
Okay, sir. Okay. Start. होदा सर सुरू करूया. होदा सर, may I start? पण तुम्ही सुरू करणार ना. झाले तुम्ही जॉईन मॅडम? फार वेळ झाला, अर्धा तास एक्स्ट्रा लेट झाला. हा, त्या आहेत त्या मॅडम अँकरिंग सुरू करणार ना. स्टार्ट ऑन करा की, ते व्हिडिओ ऑन करा की. मी माझं बंद केला व्हिडिओ.
Very good morning, ladies and gentlemen. A very, very warm welcome to very wonderful, beautiful day that brings us together to learn something precious. On this auspicious occasion, I would like to welcome you all for online national webinar on sustainability science, a multidisciplinary approach organized by IQAC and Department of Botany, Yeshwantrao Sawan College of Science, Karad. Stars shine at night, some stars shine at bright daylight. It's a pleasure welcome such a star, Dr. Arvind Kumar Sinha sir, Honorable Chief Guest, former Vice Chancellor, Netaji Subhash University, Jamshedpur, Jharkhand. I would like to warm welcome Honorable President Shri Prakash Pandurang Patil, Bapu, General Secretary, Shri Shivaji Education Society, Vidyanagar, Karad. I would like to warm welcome to Honorable Speaker Dr. Chandrasekhar V. Murumkar sir, Principal TC College of Arts, Science and Commerce, Baramati, Pune. I would like to warm welcome Honorable Speaker Dr. Bharat Lal Meena sir, Assistant Professor, University of Rajasthan, Jaipur. We extend a very warm welcome to all HODs, professors, faculty members, students, and audience who have gathered here from diverse places. May I request to Dr. S.A. Kirtane ma'am for welcome and introduction of Honorable Chief Guest and Honorable President.
Thank you, madam. First of all, I tribute to the great personalities, not only India, but the world also. Chhatrapati Shivaji Maharaj, Mahatma Jyotiba Phule, Savitribai Phule, Dr. Babasaheb Ambedkar, Yashwantrao Sawan Sahib, and all who have devoted their lives for betterment of the society. Honorable Chief Guest, Dr. Arvind Kumar Sinha sir, former Vice Chancellor, Netaji Subhash University, Jamshedpur, Jharkhand. Honorable President, Shri Prakash Pandurang Patil, Bapu, General Secretary, Shri Shivaji Education Society, Vidyanagar, Karad, Board for Higher Education, Vidyanagar, Karad. Honorable speakers of today's national webinar, Dr. Murumkar sir, Principal Tuljaram Chaturchand, College of Arts, Science and Commerce, Baramati, Pune. Dr. Bharat Lal Meena, Assistant Professor, University of Rajasthan, Jaipur, India. Honorable Dr. Poddar sir, Dr. Burungle sir, all my colleagues, and you all who are attending this national webinar. I feel extremely privileged and honored to be given this opportunity to welcome you all. On behalf of the college, I welcome you all and thank you for taking the time to join us today. Due to COVID-19, we are using online platform for this national webinar. All the science lectures are under the same umbrella where we will listen, think, discuss about the multidisciplinary approach for sustainability of science. Multidisciplinary approach is to find out it by using many specialized branches of learning. Its aim to achieve a common goal using knowledge from several disciplines. If we talk about the 2020, we realize that we need importance and of multidisciplinary approach, and thus I feel that to work together, the three C's are very important for us. That is communication, collaboration, and creation for the better of education and research. Thus, keeping these three C in mind, we will work together. I warmly welcome you again and thankful to Honorable Chief Guest, Honorable President, Honorable Speakers, and the attendees for sparing valuable time with us to share some ideas and grace the event. Jai Hind, Jai Maharashtra, Jai Bhim. Now, I am taking this opportunity to introduce today's Honorable Chief Guest, Arvind Kumar Sinha Sir, former Vice Chancellor, Netaji Subhash University, Jharkhand. Professor Arvind Kumar Sinha did his schooling from Jila School, Gaya, and graduated from Gaya College, Gaya in 1971. He passed SC examination in botany with cytogenetics and plant breeding as special paper from Magad University, securing first class first position and was awarded gold medal in the year 1975. After that, he joined University Department of Botany as a junior research fellow of UGC in November 1975, where he worked for nearly 2 years. Professor Sinha joined Magad University service in the capacity of lecturer in botany on 13 October 1977. During this service period, he was promoted to post of reader in 1986 under the merit promotion scheme and to the post of university professor in 1993. Professor Sinha served as head of department of botany at Gaya College, Gaya, and also founder head of the Department of Biotechnology till retirement, that is 31st December 2017. He was offered the post of Vice Chancellor of Netaji Subhash University, Jamshedpur, where he joined on 15 December 2018. Professor Sinha is credited with publishing 70 research papers in national and international journals. He has guided 27 students for their PhD degree. He has attended many seminars and conferences and presented research papers. He also chaired certain sessions. He organized many national and international seminars at Gaya College, Gaya, one of which is memorable, which was organized in February 2010. In this seminar, His Excellency and Missile Man of India, Dr. APJ Abdul Kalam, was the keynote speaker, and Sri Nitish Kumar, Chief Minister of Bihar, was the chief guest. Professor Sinha is associated with many scientific societies such as Indian Science Congress Association, Indian Botanical Society of Cytologists and Geneticists, and Mendelian Society of India. He is also fellow of Mendelian Botanical Society and Mendelian Society of India. He is also secretary of Mendelian Society of India, which published in International Journal Mendel. I am very happy to share one thing that during my PhD thesis, I am very lucky that I have get guidance of Dr. Sinha sir, because of you, I can submit my PhD. Thank you. Thank you, sir. Further, let me take an opportunity to introduce Honorable Sri Prakash Pandurang Patil Bapu, President of today's inaugural function, and General Secretary Sri Shivaji Educational Society, Board of Higher Education, Karad. He served as Assistant Personal Manager at Bharat Forge Limited, Pune, founded by renowned businessman Dr. Nilkantha Kalyani, who was member of Governing Council of Sri Shivaji Education Society. During his service in Bharat Forge, he completed his LLB degree from ILS Law College, Pune. Then, voluntarily resigning the service, he preferred farming at hometown Karad. Sir has been interested in farming and doing experimentation in it. Sir started in administration of Education Society, later in coordination with Honorable Ramrao Pawar, Secretary of the institution. He involved in the administration of the institute and now working as a General Secretary of the institute from last 12 years. Due to his devotion college is going towards the excellence. Sir is very attentive at the welfare of students. He is very much careful about the smooth conductance of regular academic activities of college, especially well-being and welfare of all the students of the college. He is always ready to pay attention towards the hostel students and also the students which are coming from rural areas. He was as a chairman of Sangam Sahakari Patil, Piti Sangam Sahakari Pani Purota Mandal, Karat. He always inspires us educational conferences, workshops, etc. So we are enjoying the work in the campus. We are getting his continuous support, guidance, and inspiration for conduct of such activities. Thank you, sir. Thank you. With this brief introduction, I stop here. Thank you. Thank you all.
Thank you, ma'am. May I request to Dr. S.B. Kingar, sir, Principal of Yeshwantrao Chavan College of Science, for giving introduction of our college. Please, sir.
Good morning to all. First of all, my humble tribute to Honorable Sri Yeshwantrao Chavan Sahib, Honorable Sri P.D. Patil Sahib, So Vinitay Chavan. Good morning and welcome to all in one day online national webinar on Sustainability Science, a multidisciplinary approach, organized by Internal Quality Assurance Cell and Department of Botany, Yeshwantrao Chavan College of Science, Karad. I feel honored to welcome Honorable Balasaheb Patil, Minister of Cooperation and Marketing, Government of Maharashtra, Guardian Minister Satara, and Honorable Chairman of Sri Shivaji Education Society, Karad, Board for Higher Education. Today's President of Inaugural Function, Honorable Prakash Pandang Patil, General Secretary, Board for Higher Education, Sri Shivaji Education Society, Vidyanagar, Karad. Honorable Chief Guest, Professor Dr. Arvind Kumar Sina, former Vice Chancellor, Netaji Subhash University, Jamshedpur, and Honorable Speakers, Dr. Chandrasekhar V. Murumkar, Sir, Principal, TC College of Arts, Commerce, and Science, Baramati, Pune, and Dr. Bharat Lal Meena, Assistant Professor, Department of Physics, University of Rajasthan, Jaipur, Rajasthan. I'm here to introduce my college, Sri Shivaji Education Society, Vidyanagar, Karad, for higher education, founded by Honorable Sri Yeshwantrao Chavan Sahib, former Deputy Prime Minister of India, and established this college in June 1958 as a science college, Karad, with an objective of providing education in a science students to all science students of the Karad and surrounding area in Maharashtra. To keep his memory alive, the college was renamed after him in 1986. The college building inaugurated in 1960 by the then President of India, Honorable Dr. Rajendra Prasad, is located in a sprawling campus of around 40 acres and has flourished under the able stewardship of Honorable Sri P.D. Patil Sahib. Now the college successfully runs by Honorable Chairman Sri Balasaheb Patil, Cabinet Minister, Cooperation and Marketing, Maharashtra State. Today, Yeshwantrao Chavan College of Science, Karad, is one of the premier educational institutions in this region. The college is a granted institution affiliated to Shivaji University, Kolhapur. Our college is accredited B++ level by NAC in 2017. The college is also ISO 9001-2015. The college offers total 13 courses at the graduation. That is also the UGC has sanctioned the 3 years course of agricultural production of biofertilizers and biopesticide under the skill development scheme. The college has a facility of postgraduate courses in microbiology, chemistry, and botany. College has a recognized research institute for PhD in microbiology, zoology, and botany. MPhil courses in botany and zoology are also being offered in this college. 3 professional courses such as a BSc in Biotechnology, BSc in Computer Science, and BSc in Computer Science Center at a graduation level. From last 2 years, this college has started the MCA course recognized by YCMOU Nashik. The college has also received several grants for the major and minor research projects and for the infrastructural facilities from funding agencies like UGC, CPCB, and DST-ACRB. To achieve academic excellence, our meritorious students have consistently occupied top place in a board and university merit list. In the academic year 2017-18, the college has received award of maximum number of merit scholarships in urban areas as well as in a science stream of Shivaji University, Kolhapur. Sanstha has also started YB Chauhan Competitive Examination Coaching Center to provide a guidance to the students who come from the rural background to develop a good administrator and to create the awareness among the students for various competitive exams. In short, the college has the facilities to educate the students from the KG to PhD. Thank you for all the dignitaries. Thank you all.
Unmute हो गया. आभार.
Thank you, sir. We are excited to hear some valuable words by our today's chief guest. So we kindly request respected Sir Dr. Arvind Kumar Sinha, Sir, former Vice Chancellor Netaji Subhash University, Jamshedpur, to continue our webinar by sharing some words with us.
Thank you very much. First of all, I must thank Dr. Susma Kirtane for reading my biodata in a very good way. Thank you, Dr. Susma. Good morning to all of you. Subh Sakal, Namaskar.
Namaskar.
President Sri P.P. Patil, General Secretary of Sri Shivaji Education Society, Vidyanagar, Karad, Principal of the College, Dr. S.B. Kenigar, Speakers, Dr. Chandrasekhar, and Dr. Bharat, Organizing Secretary, Dr. Susma Kirtane, members of the organizing committee, anchor, academicians, friends from the Mendelian Society of India, students, ladies and gentlemen. I am highly honored and feel privileged to address the gathering of the academicians on this occasion. First of all, I would like to draw your attention towards one thing by which I was very much impressed. In the letterhead of the college, I found one quotation and one slok which appealed me a lot. The quotation reads as, "Be one with the downtrodden and the underprivileged." This quotation fits very well for the college, as the college name is after a great social activist of all the time and one of the great politicians of the country, elect Y.B. Chauhan, who during his lifetime fought for the cause of downtrodden and underprivileged. I salute Y.B. Chauhan. The slok reads says, "Jnanam param balam jnanam sarvjan hitaya विश्व जीवन जीवनामृत ज्ञानम." इसका अर्थ यह है कि ज्ञान ही बल है, ज्ञान से ही सभी का हित होता है और ज्ञान ही विश्व का जीवन अमृत है. Of course, college is a temple of knowledge which makes a person sensitive about the feelings of the underprivileged and downtrodden. I am very much impressed by the sayings of principal who told about the details of the college. The college is really good and hope the college will certainly get NAC A in the coming year.
Thank you. Thank you, sir.
I wish so. Now coming to the webinar's topic. Today's topic is Sustainability Science, a multidisciplinary approach. This topic is interesting, but at the same time, very challenging. Sustainability science is the study of the dynamic relationship between human and the environment. It is an emerging field of research dealing with the interactions between natural and social systems and with how those interactions affect the challenges of the sustainability. Therefore, this science is concerned with addressing practical challenges caused by climatic change, habitat and biodiversity loss, besides others. Broadly, can be said that sustainability science is focused on the interactions between human environment and engineered systems. Hence, this science encompasses many subjects, making it multidisciplinary. The word sustainability requires direct action to conserve, protect, and enhance natural resources. Therefore, this becomes a wide-ranging term and can be applied to almost every facet of life on the earth. Long-lived and healthy wetlands and forests are the typical examples of sustainable biological systems. We all know that invisible chemical cycles, redistribution of water, oxygen, nitrogen, and carbon through the world's living and non-living systems have sustained life since the beginning of the time. As the Earth's human population has increased considerably, natural ecosystems have declined. This has led to changes in the balance of natural cycles, which have a negative impact on human beings and other living systems. Therefore, sustainability becomes essential, which is must for stabilizing the currently disruptive relationship between Earth's two most complex ecosystems, human culture and the living world. Here comes the significance of the sustainability science. Researchers in the field and their proper application and implementation can make our lives sustainable. This science actually emerged in the 21st century as a new academic discipline. This new field of science was officially introduced at the World Congress, Challenges of a Changing Earth 2001 in Amsterdam, organized by the International Council of Science, the International Geosphere Biosphere Program, the International Human Dimensions Program on Global Environmental Change, and the World Climate Research Program. The field reflects a desire to give the sustainability a stronger analytic and scientific underpinning as it brings together the disciplines across the natural and social sciences, engineering, and medicines. So sustainability science is focused on examining the interactions between human, environment, and the engineered ecosystems. All these together contribute to solutions for complex challenges that threaten the future of humanity and the integrity of the life support systems, such as climate change, biodiversity loss, pollution, and land and water degradation. This science has developed from a new research field into a vibrant discipline in its own right. The science is characterized more by its research purpose than by a common set of methods or objects. Sustainability science can be subdivided into traditional disciplinary-based science and a transdisciplinary science. Traditional based science consists of more descriptive, analytical, and basic science, while transdisciplinary science is characterized by reflexivity and applicability. The emergence of transdisciplinary science can be considered a new step in the evolution of science. According to different scientists working in this field, this science possesses three characteristics. First, it may be basic or applied research, but it must be purpose-bound. That is, it must be aimed at action. Second, it provides integrated analysis and assessments. Integrated assessment is a reflective and iterative participatory process that links knowledge, that is science, and action, that is policy. It is an interdisciplinary process combining interpreting and communicating knowledge from diverse scientific disciplines and non-scientific sources in such a way that the whole cause and effect of a problem can be evaluated from a synoptic perspective. Third one is this science must be interdisciplinary, conducted in a way which allows the integration of its result in an interdisciplinary context, bringing disciplines together to achieve greater consistency in approaches between them. Sustainability science has been introduced as an inter and transdisciplinary academic program in the higher education system around the world. As we are aware, the environmental degradation and poverty on one side and ecological imperialism on the other are the main threats to sustainability. Hence, there is a need to integrate and reshape the natural, technical, social, economic, and ethical sciences to accommodate the current and future needs of humankind. The impact of environmental degradation has no boundary, and therefore there is a need for common effort to control the degradation at global level. The number of academic programs in the field of sustainability science is growing regularly across the globe. Some pioneer institutions include Arizona State University and Harvard University, USA, University of Tokyo, Japan, Leuphana University, Germany, and Indira Gandhi National Open University, New Delhi, India. Sustainability science research is now conducted in a multitude of countries and increasingly involves international collaboration, mostly between neighboring countries. Up till now, 15 research clusters have emerged, with the main themes being urban planning, rural sociology, energy, health, soil, wildlife, agriculture, fisheries, ecological economics, and forestry. In our country, an Indian Institute of Sustainable Development was started at New Delhi in the year 1990, focusing mainly on biotechnology, nanotechnology, blue economy, water conservation, organic farming, clean energy, sustainable agriculture, reduce, reuse, and recycle, health for all, electric vehicle, and carbon footprint reduction principles. Interdisciplinary subjects like biotechnology, environmental science, etc., are being taught in our country in different institutions. But I think there is an urgent need to focus seriously on the research programs in the field of sustainability science throughout the country, and researchers as well as policy makers of the country must come together to lessen the environmental hazards. One more thing I would like to say. that scientists and policymakers who are engaged in this field must ponder for further advancing scientific understanding of human environment systems, for improving linkages between research and policy communities, and for building capacity to link knowledge with action to promote sustainability. At last, I would like to appeal to policymakers and scientists that they must guide the human race living in a period of burgeoning awareness of the conflict between human activities and environmental constraint, so that our fragile and endangered planet, with the natural resources already overtaxed, may be saved. Going green and sustainable should be our slogan, which will certainly maximize the benefits from an environmental focus. With these few words, I inaugurate the webinar and congratulate the organizing committee members for organizing the webinar on a wonderful topic. Hope we will be benefited a lot by the speech of the speakers for speaking on interdisciplinary topic. Thank you very much. पुनः आप लोग सभी को नमस्कार और प्रणाम.
Thank you, sir, for giving valuable information and give prize time to us. Thank you, sir.
Okay.
Because of some uncertain avoidances, our Honorable President, Sri Prakash Pandurang Patil Bapu, General Secretary, Sri Shivaji Education Society, Vidyanagar, Karad, are not here, but he has given best wishes to our program. I would like to invite Ms. PM Ghadge ma'am for giving introduction of honorable speakers. Please, ma'am.
Thank you, ma'am. Good morning, all the precious dignitaries today. To begin with the knowledge sharing platform today on behalf of all the staff of Yeshwantrao Saman College of Science, Kara, I would take this opportunity to welcome our renowned speaker, Dr. Chandrasekhar Basantrao Murumkar, MSc PhD, Principal Tujaram Chaturchand College, Baramati, from last 11 years. He is a member of Academic Council, Savitribai Phule, Pune University, Pune. He has been crowned with Best Principal Award by Savitribai Phule, Pune University, Pune in 2017. Under his guidance and era, he has been facilitated by Best College awarded by Savitribai Phule, Pune University, Pune in 2017. NAC re-accredited A+ CGPA 3.55. He is also the achiever of Lifetime Achievement Award, Pearl Foundation, Madurai in 2017, and Best NAC accredited A-grade college award, Pearl Foundation, Madurai 2017. Further, he has also won the Best Green Innovative Green Campus Institution Award, Pearl Foundation, Madurai 2017, and Best Renewable Energy Implemented Institute Award, Pearl Foundation, Madurai 2017. Specialized in plant physiology and environmental physiology, he carries a lot of teaching experience, more than 33 years, research experience of more than 35 years. He is a recognized PhD guide of Savitribai Phule Pune University, Pune, and Solapur University, Solapur, and referred for doctoral work in botany at Shivaji University, Kolhapur. Published more than 30 national and international research papers. Delivered more than 17 lectures of scientific, temperate, and social awareness. Worked as a resource person in national and international conferences. He is a member of editorial and advisory board of Annals of Plant Science, California, Indian Journal of Plant Physiology in New Delhi, Advances in Plant Science, Muzaffarnagar, Indian Journal of Odyssey of Ayurvedic Research, IJOOAR, Sangli, Ankit Institute of Management Studies, AIMS, Baramati. His honors and awards: College of Academy of Plant Science 2015, Mahatma Jyotirao Phule Award in 2019 by Bhauram Kale Sanskrit Shanti Academy, New Delhi. Appointment as chairman for Science Faculty on Maharashtra State Bureau of Textbook Publication, Production and Curriculum Research, Baramati. Member International Circumstance Designing Board, State Government of Maharashtra, APSI International Plant Science Award in 2014, APSI Eminent Scientist and Conference Organized Award in 2012. Best Teacher Award by Social Welfare 2012, Resource Person for a Value of Flower, Himachal Pradesh in 2007, Best Paper Presentation at International Conference on Plant Physiology in 1998, National Doxnia Fellowship in 1979 and to 1981. I would like to hand over the charge to Honorable Dr. C.V. Murumkar sir to share his knowledge to our dignitaries. Please, sir.
Good morning. I hope that I am audible to all. Indeed, it's my pleasure that a very renowned institution in Maharashtra, Yashwantrao Chavan College of Science, Karat, are organizing a national webinar on a very concurrent topic, sustainability science, a multidisciplinary approach. I'm very much happy that an opportunity is obviously given to me to speak on a very interesting topic on this occasion. I'm privileged that Honorable Principal of the College, Professor Kengar sir, has very vividly introduced the institution, but I know that the repute of this institution is much more higher, because I recall my memories somewhere in 1984 when this institution organized its first national conference on environmental sciences. And I'm privileged again that I was the participant at that time as a student. So after almost more than 35 years, I also congratulate the General Secretary, Honorable Sri Prakash Ji Patil sir, for creating this opportunity for the young buddies, researchers and students to come under one platform to enrich their knowledge, information, and obviously their urge to learn more. Indeed, it was my pleasure to hear from Professor Arvind Kumar Sinha, ex-VC, Netaji Bose University. The way he has presented the role of sustainability in the current 21st century scenario, indeed, it's really valuable, and obviously it is the issue of an urge one has to take into consideration. Obviously, I must recall what the UGC and have identified a threshold area in almost coming 30 to 35 years. Obviously, sustainability is one of the area where each and everyone is supposed to give its contribution. I also express my thanks to Kirtane ma'am for keeping faith on me and inviting me for this prestigious lecture. The IQC committee of this college, the IQC coordinator, Dr. Poddar sir, Kirtane ma'am, her colleagues, the fellow students, the researchers, the professors, and another speaker, Honorable Dr. Bharat Meena, who is supposed to join after me. Wish you all a happy new year. And also this new year has brought several new faith as we are now in the phase of receding the corona pandemic. Again, everything is in the new mode of new normal. And again, we are all eager action mode of our learning protocol. Obviously, as far as the learning is concerned, if the learning is interesting, everyone can learn by heart. And if the learning is not interesting, then even though it is repetitive one can't understand. And because of that, I must congratulate Kirtane ma'am for giving me an opportunity to speak on a topic which is not related in biology, but it is included and it is an integral part of the biology. I feel that somewhere in the past, few years ago, Kirtane ma'am had listened to me when I was speaking something out of the box in biology. And she reminded me that she wanted to again refresh not only herself, but her colleagues also. And so today I have chosen a topic which is rather very interesting one. And the topic is understanding biology by the mathematical way. Obviously, we know well that in India particularly and in Maharashtra in person, the students in the 11th and 12th standard, they are always having a dilemma because up to the 10th standard, they are not having any option and they have to go for the mathematics. But the moment they join the science stream in the 11th and 12th standard, the first decision as a youth they take that when they opt for the biology, they omit the mathematics. And they feel that henceforth in their life, the mathematics is not supposed to play any role at all. And so their teachers, their parents, their neighbors, their friends, all, they anonymously tell him that if you want to be a doctor, forget mathematics. If you want to be an engineer, forget mathematics. And in this way, unfortunately, the mathematics has one of the most threatening subjects for the biology students. And because of that, I have deliberately chosen this topic. And let us see now how this topic is into. Again, it is going to bring us several interesting approaches in coming future also. So by taking the permission of Honorable Sinha sir, who is the today chief guest and the speaker, I request the IT people of this college to let me share my screen so that I can go through my presentation. I feel that my screen is visible to you. Is it so? Can you see my screen?
Yes, sir. Yes,
Yeah,
sir.
very good. So now let us begin. I know that already it is too late, and from mathematical point of view, I am 1 hour and 13 minutes late. But even though, let me go through. So we are going through understand the biology, and we have to see that at each and every step there is a mathematics. So biology cannot be learned, the biology cannot be understood without the knowledge of the mathematics. And so I feel that a biology person must know the mathematics in one way. And secondly, mathematics alone cannot be taught without taking a hand of a mathematics or without taking a hand of a biology. And so mathematicians are poor in biology, and obviously the most biologists are poor in mathematics. So this is vice versa. I suppose someone is playing with the screen, so I request not to do so. So there is a hate and love relationship with mathematics, and obviously then biology will be the great mathematical frontier of the 21st century. Now this is the quote which has been mentioned by the Stewart, a very eminent mathematician who has won the prestigious Mathematics Olympiad Award, and he was the president of Mathematics Olympiad in 2001. So obviously biology will be a great mathematical frontier of the 21st century. If it is so, let us try to understand what he exactly wants to say. Mathematics is a way to describe the complex systems. And when we in biology speak, we speak in two different levels. We speak as an individual, which can be called as an odd ecological component when we study a single plant. We take an example. Or on the contrary, we talk about a single plant as a representative of a population. And the population may be a part and parcel of this ecosystem. And so obviously when we assume so many things, this assumption obviously is on the basis of a mathematics. So mathematics is a way to describe the complex systems. For example, there are thousands of species in a tropical forest who are interacting in a complex ways with the biotic factors as well as abiotic factors, with the associations, combinations, computations, and obviously the several biological abiotic components like soil, weather, temperature, light, and so on and so forth. So all this, if at all we want to put it in the figures, in the numbers, that is nothing but the mathematics. So biology represents the challenges into the complex, and mathematics may help us to approach such a type of complexity. So mathematics represents a way to extract the straightforward consequences of a series of assumptions. So this is nothing but it is a logistic analysis. It is a logistic approach of what our understanding of the present scenario, and not only that, what can be the future consequences. So if at all we want to go for the predictions, there has to be a linear presentation, and this linear presentation obviously can be presented in the form of mathematics. So obviously, as we know, a simplest mathematical formula that if x is assumed, then obviously we can go for that y, that is its product or its result. This does not only allow us to think clearly, but to perform the mathematical experiments in the systems in which the real experiments are impossible. Obviously, I must take an example of the genetic research and genetic evolution. Obviously, when we were going for the predictions, that time we were trying to put our observations into the mathematical formula, and that is what we know as a Mendelian laws. So Mendelian laws, even though they were statements, they were nothing but they were the interferences, they were the interpretations of the observations. And obviously these assumptions obviously were put in a mathematical way, and then we tried to, and then we understood the Mendelian laws with which the genetic expressions are taking place. So when we talk about this genetic expression, we are talking about the genetic configuration and its morphological expression or phenotypic expression. And obviously this is possible only because obviously of the mathematics. Obviously after Darwinism, what we know as a neo-Darwinism, it is nothing but it is the quantitative genetics. And for that purpose, to understand this, we must know the mathematics. So as far as the mathematics is concerned, the mathematics is also dealing with all those capabilities which we are requiring to understand biology. Now, I will be focusing in my lecture more and more about the botanical assumptions, botanical examples, or botanical interpretations, because I'm a man from biology and I'm a man from the botany. But at the same time, obviously, we are supposed to take the examples of flora and fauna also, ecosystem also, because the ecosystem is plenty of not only plants and animals, but the microbial world. So obviously these are the qualities which are required. So mathematics deals with the capabilities like obviously proper thinking. So your observations must have a logical balance. And because of that, you can assume, you can hypothesize, or you can come to the conclusion with whatever the observations are there based upon the predictions. Obviously, there is another capability like analysis. Obviously, when the observations are many in magnitude, you have to draw the conclusions, you have to understand the interaction between the two, and this particular format of understanding is nothing but analysis. Obviously, there has to be a logical reasoning. Still, so far, the journey of science itself is based on this parameter, and that is a logical reasoning. When we go for the paleobotanical studies, when we go for the histological studies, when we go for the physiological studies, using the logical reasoning for this, and the one who is having the practical logical reasoning obviously can come out with a theory, and with these theories it has to be proved again and again, either with the results or the exceptions. Obviously there is another approach, and that approach is nothing but is interpretation. Obviously when things are in magnitude, in multiple dimensions, so we have to go ahead and we have to find a chronological relationship. And that chronological relationship is nothing but the interpretation. As per the biological person or biological student, we must know what is the cause effect. So obviously there is a variable, and this variable is making the changes, and these deviations, the changes which are taking place, this is nothing but the cause effect. So one has to identify the cause, and we have to see the results again. So this is a cause effect again is a mathematical component of the probability. Then we are supposed to use these terminologies, that is the correlation, probability, and distribution, because all these parameters they give us more impetus, more clear ideas, more ecological reasonings for the different components which are involved in an ecosystem. So the correlation, probability, and distribution way, the biological world which is present around us, even using these terms from statistical background, we can predict, we can assume, and we can draw the clear-cut relationship of these different components among itself. And now the 21st century is nothing but computing. When a very large data is present, this large data is given a logistic reasoning for this, and with which we can draw the conclusions. And the today's 21st world of what we know as a cytogenetics is nothing but it is a computing. It is use of knowledge and use of computer together using the softwares. We are predicting so many things. So the computers become a part and parcel of our day-to-day life. Now, when we start our discussion, we're discussing some of the very interesting issues. The first issue is that obviously when we are supposed to understand something about the mathematics, let me tell you one thing. The mathematics is as old as biology. And obviously in India, we were knowing both these components right from the beginning. We are having so many giant mathematicians with us like Aryabhatta, and we were having the Charak Samhita and many others who were very much showing the brilliancy in the understanding the knowledge of plants. So obviously the India has given, from mathematical point of view, the decimal system, which the later on the whole world accepted, because otherwise in Gregorian system they were using the score of 12 dozens, but now they have shifted to the decimal system. Obviously, there's one miracle which has been provided to the mathematical world by the Indians, and that is nothing but the wonder of a zero. And this zero has created a total new arena, new area of research and understanding in mathematical world. Now, when we are going ahead, there is one very interesting formulation which has been predicted somewhere in 18th century. And to begin with, the Leonardo Picasso, the world famous artist, he was very much excellent in mathematics also. So the Leonardo Picasso, the first European mathematician, he acquired the nickname Fibonacci. The name was Fibonacci because it's a French word. And he had studied the Indian mathematics also at that time. And in 1877, he proposed a magical numerical sequence, a unique form of sequence number using the base numbers. It was derived from the base numbers. And then this was later on proved as a regular order in the nature. So this he found that such a type of quantification, such type of presentation is a very common practice in the nature. So either it may be a biological system or it may be a physical system, right from the atoms to the universe. This number was followed, and that's why it's a very uniqueness. And almost most of the biologists are not knowing about this. This is known as a Fibonacci sequence. Now, thereon, when a French mathematician and a popularizer, that is, he was a writer at that time, the Gerald Lucas, he learned about this sequence and he wrote about his uniqueness there. So he popularized this Fibonacci sequence, and using his details, then the world understood what is meant by Fibonacci. So its sequence members have been known as the Fibonacci numbers. So I'm today discussing in my first part what is meant by Fibonacci numbers, or what is this Fibonacci sequence. So the sequence is, I have written in the first two lines, 1, 1, 2, 3, 5, 8, 13, 21, 34, 55, 89, 144, and so on. Now, what is this sequence and what is the correlation between these? The rule of the forming these numbers, obviously other than the first two, because the first is the one to start with, and the second one is the representative. So which are taken as a starting point. So forget about the two. And the rule is that the each is obtained. So the next number is obtained by adding the previous two. So how the 2 is obtained? So 1 plus 1 is equal to 2. How the 3 is obtained? 2 plus 1 is equal to 3. How the 5 is obtained? 3 plus 2 is equal to 5. How the 8 is obtained? 5 plus 3 is equal to 8. So this is the way the sequence goes on. And this sequence, 1, 2, 3, 5, 8, 30, and so on and so forth, this sequence is followed in morphological presentations in the biological world. And that's why it's got the very unique, and it is very interesting that almost the world, the biological world which we are seeing, the morphological presentation which we are seeing, it is fitting and it is following this formula. How it is? See, the number of petals in the flower, they are always in this whole sequence. Either they may be 3 or they may be 5. If at all they are not 5, then they go ahead with the 8, 13, 21, 34, and so on and so forth. So these are some of the common plants which we are knowing. So we are knowing the trimerous flowers with us. Then we are having the pentamerous flowers with us. And then we are having the flowers which are having the more than number more numbers of the petals, or maybe the stamens, or even maybe carpels, but they always follow this number. And remember how this number is obtained from biological point of view. Always there is a single parental cell. The single parental cell gives rise to two by division, a mitotic division, and from the mitotic division it follows further. So it is following the binomial pattern of architecture of cell division. But later on, these cells always follow the rule of unequalness. So both the cells, they are never of the same potentiality. Always the one number becomes dominant and another number becomes suppressive. And because of that, in biological systems, what we find is always an uneven numbers, odd numbers. It is never a 2, 4, 6, and 8, and so on and so forth. But it is always 3, 5, 8, and 13, and so on and so forth. And this is simply because the rule of uncertainty, the rule of uncommonness is existing. So if at all the two forms are present, or the two cells are formed, or daughter cells are formed, both are not following the same pattern, because that is true only in the microbial world. But when we go ahead with the evolution, obviously out of the two, one becomes dormant or one becomes suppressive, and only one will continue. And because of that, we are going to get these odd numbers. Obviously these numbers. So you can see that what we see as a natural character, what we see as a natural form of a biological pattern, actually it is following the mathematical formulations. A typical also case. Now, when we go ahead with this, when we are talking about the linear form, that is in number form, we are following that sequence, what is known as a Fibonacci sequence. But when we talk in terms of a circle, then obviously the circle is having 360 degrees angle. So in that case, when we talk in terms of a circle, a typical case occurs for an angle of 135, which is a 3/8 part of a full circle. If we say that the first leaf is at the angle of a 0, then the second leaf will be definitely at the position of 135 degrees. And the third will be at 230, and so on and so on and so forth. What is this? This is nothing but it is giving us an idea that the angles of successive leaves on a single branch or arrangement of the leaves on a single branch, they are following this Fibonacci sequence. Now, this is very important from biological point of view. Why? Because when these leaves are getting developed, when they are getting developed, automatically they are trying to avoid the overlapping. And when they are not overlapping, obviously they are going to get the maximum number of sunlight. And so they are going for the optimum photosynthesis. I request someone who has unmuted its computer. So we are talking about now the arrangement of leaves on a single branch, or the development of leaves on a single branch. And they are following this Fibonacci sequence. The angles of the successive leaves are the integer multiples of 135 and subtracting 360 degrees, because what is remaining? Whenever the numbers become larger than the full nocturne, we obtain the sequence of angles with the corresponding fractions of a full circle as given below. So if the angles are 0, 135, 270, automatically we go ahead after 360, that becomes a 45, 180, 315, and so on and so forth. So that is a full part of the circle. In fraction of a circle, if we say it is 0, 38, 68, 18, 48, 78, and so on and so forth. What does it mean? It means that we are talking about the developmental biology now. Dear friends, I know that you are the students of the botany. The fraction of a turn between the plant's successive leaves. So youngest leaves and the oldest leaf, when they are arranged on a branch, they are following this pattern of angular orientation. And this angular orientation is known as a texis. Unfortunately, we are knowing a lot of things in biochemistry and physiology, but we have forgotten these basic morphological patterns which have been exhibited. So dear friends, the texis is nothing but it's an arrangement of leaves on a single axis from the point of its angle in 360 degrees angle. So you can see in the grasses we are having the 1/2 orientation. That is, the leaves are present in 180 degrees to each other. What does it mean? That's why we call the grasses as they are having the distichous leaves. Distichous means the leaves which are present in two orientations. Obviously, when we go for the another component like gymnosperms, we find this 1 to 3 orientation. That is, in 360-degree angles, the leaves are arranged in a 1 position, 2 position, 3 position. So automatically the leaves do not overlap with each other. And this is very important. And this is important because of getting the sunlight. And that's why it's called as a canopy bioenergy synthesis. So when we talk about the canopy development, when we talk about the canopy magnitude, then such a type of architecture is very much interesting to understand. I suppose you might have seen the leaves of a mango. तुम्ही जर आंब्याची ढाळी जर हातामध्ये धरून बघितली तर वरच्या बाजूला तुम्ही कितीही खाली पान असू देत, अगदी 20-25 पान असली तर प्रत्येक पान स्वतंत्रपणे आपल्याला बघता येतं. The same is true with the coconut plant. The same is true with the palms. The same is true with the cycas. So when you see from the top that not a single leaf is getting overlapped by other leaf, and that's why each and every leaf is getting the maximum sunlight, and so they can go for the optimum photosynthesis. And this is based on the mathematical basis of orientation of the leaves, which is known as the texis. So I have shown some examples which are having the opposite leaves in the elves, then the cherry leaves which are having the following the pattern. What is meant by leaf 5 and the leaf number 5? They are in the same direction, whereas the remaining 4 leaves in between, they are of different orientations. They are at different angles, and so there is no any overlapping at all. And so in this way, you can take on any leaf and you will follow, and you will find that these leaves also, they are following the Fibonacci sequence. So very interestingly, when we are putting it in a linear fashion, in a numerical form, the same can be presented in a graphical form. And so this makes a spiral. So what is a spiral? Now we are putting the squares. You can see at the center 1 plus 1. So it becomes 2. 2 plus 3 becomes 5. 3 plus 5 becomes 8. 8 plus 13 becomes 21. And 13 and 21 becomes 34. In this way, this is a parabolic enhancement of the circle. And it is following again the Fibonacci number. So this Fibonacci is the base of mathematics. Fibonacci is the base of following the natural rule, and this natural rule has been placed in expression in mathematics, but its expression in morphological way we see in a biological form. And this is the best example that when we are finding this architecture of arrangement, they are following this golden angle. So you can see the golden angles when they are just less than golden angle, we will find these different patterns. And you will realize that these different patterns are nothing but these are the arrangement of the leaves, these are the arrangement of the stamens, even these are the arrangement of small florets, or what we know as a disc florets in the sunflower. See this architecture. And so this is the Fibonacci sequence. Now you can see that the arrangement of the disc florets at the center of the sunflower. I've just taken the sunflower as an example, but you can take on any plant. Either it may be from the Caparidaceae, it may be from the obviously Asteraceae, or it may be even from the Euphorbiaceae. You will find that they are following this particular Fibonacci sequence. And then obviously the Fibonacci sequence, when it is put in a formulation form, in the trigonometric way, it is called as a golden section number, which is known as a phi. You can see the symbol, and this phi is being a constant number, which is being used in expressing the morphology in biology. either it may be in the plants as well as in animals. So obviously, when we use this 1/5, we get this number, and this is called as a golden string. So this golden string starts with the 1, 1, 0, then 1, 1, 0, 1, 0, and in this way we find a sequence which is called as a golden string, and this golden string has been presented by just calculating the phi through its relationship ratio. And remember, this is nothing but, this is the simplest basic of software formation or software developing. This is nothing but, it is a digital language or binomial language. So the same binomial language is being used now to develop in computing systems or to develop the softwares. So ultimately, Fibonacci number, it began with the orientation and expression of the cell division and its proliferation, and it was following a particular pattern, and this pattern was called as a Fibonacci sequence, which was identified by the Picasso. And then we have seen in a series of examples, either it may be in a linear example, or it may be an angular example, or in a graphical presentation. They are following a very common pattern of expression, and because of that, the Fibonacci is one of the basis of understanding the morphological architecture of expression of what is being a part and parcel of developmental biology. So obviously, we will now discuss some of the applications of mathematics, but I am not giving you a prolific approach, but I am going to give you the glimpses where the mathematics is involved and how it is involved, so that obviously you can work it on and you can understand what is the very essential role of mathematics in understanding the biology. Obviously, the first component is nothing but, it is a biodiversity. And when we try to understand the ecosystem, obviously these are the formats with individual species, where you can take a single example and you study it, or you can go for the population, that is the species which is present in multiple forms, or the population may be present in an ecosystem. So the many populations come together to form an ecosystem. So obviously ecosystem may be of a given area or given locality, but in the world there are several areas which are the hot spots, or hotspots are nothing but these are the ecological niches or the specific ecosystems which have been developed. For example, we are having the glacier ecosystem, grassland ecosystem, semi-forest ecosystem, tropical forest ecosystem, even the deep ocean ecosystem, then estuary ecosystem, and so on and so forth. All these are hotspots, and they together with interaction, they form what is known as a biological world, which we study as an earth. So obviously, starting from a single biological component, from ecological point of view, we go ahead and we can try to understand what is seen or what is presented and how it is being interacted in the earth level. So obviously, the next component is nothing but the biodiversity. And when we try to understand the biodiversity, we have to study the dynamics of the biodiversity, because the biodiversity is never stagnant, it is never consistent, it is never constant, but it is changing. And when the biodiversity is changing, obviously we have to follow some of the reasonings for that, logistics for that. So habitat loss is the leading cause of biodiversity decline. Everyone is knowing, because there is always a stress of habitat and always a stress of environment on it. So the mathematical models, however, they predict that beyond a threshold of the habitat destruction, the population goes for extinction. So it means that when there is no any equilibrium, or when the equilibrium is disturbed, obviously then the ecosystems, they undergo changes, and these changes formation of a new species and always removal of unknown or old or unsuitable species. And here there is a rule of Darwinism plays an important role, that is the survival of the fittest. So how they are surviving and why they are giving out, or why they are sustaining, why they are becoming dominant, these can be predicted with the mathematical models, because there is a relationship of a population and its environment, and all this can be put forward in mathematical terms. Now, at these critical values, the populations and the communities, they are always at the edge of extinction. So remember, the life on the earth is very fragile. The ecosystems on the earth are very fragile. So there is not only a competition and association in between the biological forms. For example, on one side, we are having the plants with us, but there are several animal life, or there is a large animal life, which is depending on the plants. So obviously these two are having a correlation among themselves, and also they are having one step ahead or one energy level ahead, that they are interacting with each other in the form of a prey and predator. It's a food chain, and this food chain has to be understood. And because of that, the ecosystem or the populations, they always remain dominant. So automatically, when the predators are more, the ecosystem gets endangered. And when the ecosystem becomes dominant, automatically there is a problem for the preyers. So this is always a new dynamic ecosystem which is accepting the new changes, and it is deliberately removing the strategic ones or rigid ones. Obviously, there is no any relationship anymore between the intensity of the perturbation. Perturbation means disturbance, and the magnitude of its consequences. Means once the disturbance is started, this rule says that even though then we remove the disturbance, the process understand, and we are talking this about in a very long way, and that is the effect of stress. So even though we remove the stress, the changes we are supposed to take place in the plants, they are not going to change. It will continue, and then automatically the final reasoning will be the same. Either the plant will become the salt tolerant, or the plant will become salt sensitive, and it will be removed. The same is true with the several ecological forces which are applied. For example, the best example of the ecological force or the environmental force is nothing but the pollution. And we can see now that so many times we are trying to control the pollution, so many measures, so many cares we are taking for controlling the pollution. About the ecosystem, which is now becoming more and more fragile, it is not changing, it is not coming back. On the contrary, it is moving forward, and there is a large magnitude of destruction and deterioration which is taking place. This is simply because it is following the mathematical formula. Now, when we talk about the, again, biodiversity, and we were supposed to study ecology, generally we use these terms. And using these terms, we try to classify, we try to identify the correlationship of one species in a given habitat. So how we are studying? Obviously, we are using either the quadrat method or transact method. But what we are studying, how we are understanding the relationship? We are understanding the relationship in the terms of a frequency or abundance or a density or a dominance. Frequency means how frequently a specific single species is getting repeated in a given area. How much quantification number is present in a given area. What can be the density? So how much is the population in a given area, or either in one square meter, 10 plants are present or one plant is present, or in 100 square meters, if one plant is present or 10 plants are present, that is the density. And obviously we have to go ahead with the last component, dominance. Remember, to understand this ecology, all these parameters, if at all we want to study, they are the basis of mathematics, because they are to be used or they are to be understood by using a mathematical formulation. And because of that, even to understand the ecology, we cannot omit the mathematics from our life. Now, when we are talking about the ecology and when we are talking about the population, we go ahead one step, and what is known as the population dynamics. It means now we are talking in the ecosystem. We are talking at the populations now. And so when we are talking about the population, the Hardy-Wimber's law in population genetics, it is following and it is very equivalent with that of Newton's first law of physics. And what this law says, if no force is applied into a population, for example, either it may be a natural selection or migration, then the population will remain in a genetic equilibrium. For example, the population is the P and the Q is the variable. If both are not changing, then it will be an equilibrium. It will be constant. But dear friends, as we know that the biological world is not a constant at all. There's always a competition. There's always a genetic drift. There's always a mutation. There's always a hybridization within the population. And that's why the new species are coming up. And these new species are preparing, or they're making a stress on the previous parental population. And at the same time, the new mutations or new variants or new hybrids which are forming, they are subjected to changes in the environment. So there is a stress of the environment also. It may be the nutrients, it may be the food, it may be the light, it may be the temperature, it may be the water, or it may be other parameters like prey, or it may be the disease. And all these parameters, they're interacting together. And because of that, when we see and when we study the ecosystem, we always say that the ecosystem is a dynamic, it is having a dynamic equilibrium. So this dynamic equilibrium is depending on these two parameters. P plus Q is equal to equilibrium. So if at all we want to calculate this equilibrium, we have to make a constant. Now see the population dynamics. How it is related, as I told you, the number of herbivores, they are always more. You can see now it is a picture of a grassland in the Africa where the herbivores are present in thousands in a given square kilometer. But in the given square kilometer, the predator, the final predator or the tertiary predator, like you can see, number of lion, only one. Or how much family will be there, only one. So when the 1,000 these herbivores are present, only one cheetah is sufficient to maintain the equilibrium of the population. And this can be proved mathematically. And because of that, you can see when the herbivores increase in number, automatically the predators also increase in number. And these predators, they control the number of this population. Not only this, these predators are also being infected by the viruses and microbes and so on and so forth. So this is nothing but it is called the population dynamics. So whenever in given threshold, if the population increases to some extent, automatically it is over controlled, over regulated by the environmental factors. And that's why this can be proved mathematically. So the population genetics is one of the fields with the highest mathematical development. Partly this is due to the extraordinary long time scale in which the evolutionary process take place. So obviously we know that we can study the present day ecosystem, but we are supposed to only predict what can happen after 50 years or 100 years or 200 years or even after 1000 years. But by studying the paleobotany, by studying the paleontology, or even by studying the fossil records, we can assume what must have taken place previously. And from this, we can draw the deductions. We can form a pattern of evolution, how it must have taken place. But here, the mathematics is playing a very important role. Here, we can add the figures, we can prepare a program, and this program is going to give us some idea about the impetus of this role of the ecosystem, what can be its morphological fate, or what can be its morphological architecture and orientation after a stipulated given time. And because of that, the population dynamics is one of the way where it can be studied using the mathematical formulas. For this example, I will take a small example. The models of population ecology, they describe how a population changes with time as a function of its own density or the density of a predator or a parasite or a competing system. So always there is a competition, or there is a food relationship, or there may be a disease relationship. So there is always another parameter, external parameter, who is controlling the population. And this can be put in a formula, as I told you, that is a derivative y upon derivative t is equal to constant into y. That is the final dynamic equilibrium. So obviously the rate of the change of population is directly proportional to the value of population. Means when the number of population is more, the environmental parameters, the environmental constraints are much more. If the number is less, it is safe. If the number becomes more, obviously the number becomes unsafe. I will give you a simple example. In Pune, when the population was too high, there were too many corona cases. Unfortunately, in the small areas, in remote areas, when the population was very less, it was limited, the corona cases and the death rate also was very much limited. By means of these models, one can easily explore the mechanisms contributing to the stability of the population, and not only the population, but the communities, because many populations come together and they form the communities. So in this way, if I not to understand the populations or population dynamics, we are supposed to rely on these mathematical formulations. A rich mathematical development by the fathers of the modern evolutionary synthesis allowed us to merge the Darwin's theory on the natural selection with the quantitative genetics. As I told you, we use the term neo-Darwinism because Darwin was the one who has predicted on the assumptions, who has predicted the fate of the evolution, and he has used some assumptions, but these assumptions can be proved from the mathematical basis, and that is called the quantitative genetics. And this quantitative genetics is nothing but it's a new branch which has come up in the 20th century, and this is called as a neo-Darwinism. Obviously, the resulting theory has been a fascinating intellectual contribution to the understanding what forces shape life on this planet and why there is so much a genetic variation in the nature. Because if there wouldn't have been any genetic variation, because of the predation, because of the disease, all the population might have been completely wiped out, or it would have been removed from the Earth's surface. But fortunately, we are having the mutations, we are having the hybridization program, which is inbuilt in our genetic, say, dogma. And because of that, we are having a tolerance and susceptibility at different levels. You know well that even our parents and our friends and within our, some people are much more tolerant and others are not at all tolerant. They are too much sensitive. And because of that, there is a continuation of life, or otherwise, because of predation relationship, the total earth or the total life on the earth might have been wiped out much before. So the mathematics has thus been the glue bringing together the evolution and genetics. So mathematics plays a very important role in understanding the role of genetics as well as the role of evolution. For example, when we talk about the genetics, we always say that the genetic or phenotypic traits or characters, they are exhibited and they are following the rule of dominance, or they are following the rule of susceptibility. So what is this dominance and recessive characters? We are supposed to put it in a formula. So obviously, you know well that this is a simple Mendelian formula where a dominant plant, when it is crossbreeded with a recessive plant, we are going to get a combination of both. So we are having the dominant plants, recessive plants, but because of this combination, we are supposed to get a hybrid. And this hybrid may be morphologically similar to dominant, but from genetic point of view, it is totally different. So this is a formulation with which the mathematics can be giving us a new approach for predicting the observance and logical reasoning for the predictions of the future or the future populations. Another component, this is about the how mathematics we are using in our day-to-day practices in genetics. Now, when we are going ahead, let us understand something how the mathematics is also involved in another discipline in botany or biology, and that is nothing but the physiological component. In physiological component, we study the developmental biology, that is the growth and development. And when we are talking about the growth and development, we are relying totally on the relationship of the hormones, auxins, and their relationship. We do know that each and every plant is having the different phases. For example, the vegetative phase and reproductive phase, and each and every phase is having a sigmoid curve. So this developmental biology again can be quantified, because it is very important in agriculture. How much biomass is generated, how much biomass is getting converted into the food material, and how much it is incorporated in the formation of fruits and seeds. That is nothing but it is a mathematical say expression of the developmental biology. Again, one component is nothing but the morphological shape or morphological architecture of a development, and that has to be studied from the biological point of view, mathematical point of view. Again, obviously, we go for the quantitative analysis. So obviously the estimations, synthesis, degradation, then amount of quantity and how they are controlled, all this biochemical or biochemistry is using the mathematics. Also, we are using the role of these different bio compounds on the metabolism. Either it may be inorganic components or organic components, it may be secondary metabolites, it may be hormones, or even it may be the disease, or even it may be the inorganic components. And these inorganic components, they are reacting in the growth or in the development of the metabolism of a plant. And we understand this through toxicity, tolerance, and deficiency. So toxicity is a higher level, tolerance is a capability, and deficiency means it is having on a lower threshold. So all these obviously has to be put from the mathematical formulas. Obviously, we have to understand the mechanism of how the enzyme is regulating the action. It is going ahead with the forward reaction or a backward reaction, and it is having the several regulating parameters with which the product is prepared or the product is blocked. All this has to be studied using the mathematical formulas. Again, we have to go ahead in agriculture and again understanding the ecosystem using the biomass production. Miss here how the plant is taking time, how it is going right from the germination to its reproductive phase, and what time duration is taking place. And from this point of view, we are using the different terminologies. For example, we are having the plants like ephemerals, we are having the annuals, we are having the biennials, we are having the perennials, and all these are basis on number of biomass which is supposed to be synthesized, and not only synthesized but is stored. So biomass production is one of the key components in understanding the ecosystem. But from agricultural point of view, we have to supposed to go ahead. And when we talk about the biomass, it is not only the storage of the carbohydrates, but ultimately it is storage of carbohydrates in the fruits and seeds. And then we go to the next component, that is the harvest and the yield. So we harvest the seeds and fruits, and ultimately we get the yield. But many other times when we talk about the dynamics of the forest, we are talking about the biomass production. How much biomass, how much mass is produced. Ultimately, there is a biosynthesis which is taking place, as well as its regulation parameters, genetics, and ATP. All these physiological parameters are basically to be understood, or they are to be studied using only the mathematical formulations. Another very important component is epidemiology, and this is a major role which is understood. What is the relationship of the microbial world with the host? So epidemiology is nothing but it is a disease. Epidemiology has been another important field in the biology where the mathematics has allowed a rich conceptual development. For example, what does this mean? Epidemiological models, they describe a temporal dynamics. Dynamics means nothing but it is a relationship, temporary relationship between the number of hosts infected, and make the predictions such as the existence of a critical population size beyond which the diseases fade away. For example, if the disease is small, automatically the disease will be removed from the ecosystem. But if the disease size is more, automatically the population will be removed. I will give you a very simple example. In case of an infection, if the infection is restricted to a single plant, the single plant may die. But there is if at all it is a robust locust which are coming up, if there are insect or the infection is in the form of a spores is much more larger. For example, in the case of a Puccinia, if the sporulation is too much high, then the whole population will be damaged. So again, we are using the formula of Harvard's formula, that is the dynamics of the equilibrium of the population, where the disease size and the population size, they decide who is supposed to dominate. The notorious example of a virus is HIV virus, and this infectious agent which is causing AIDS in the human beings. Now these RNA-based viruses, they mutate at a very incredible rate so as to escape the immune system, because the immune system requires certain time threshold, certain period. But these viruses, they mutate at a very faster rate. And so our own mutant immune system fails to identify, and not only to identify, but to prepare the new antibodies. And because of that, they are having a very wide spread. And this is the reason for their high success. That is, the viruses, they are spreading at a very high rate in human population because of this reasoning. And this is the reasoning of rate of understanding, rate of development of antibody, and rate of spread and mutation. Obviously, the present day best example we all are knowing is the Corona-19, because the Corona-19, unfortunately, the moment we create the vaccination or we create the vaccine, the mutant gets changed, or the corona changes itself into new variant. And you know well, at the moment we are corona variety which has been identified, or the mutant which has been identified, we are all knowing that it is a Omicron which has started its journey from Africa. So the viruses are changing very rapidly, mutating at a very rapid rate. And that's why epidemiology is one of the most important, say, biological composition or component, which is directly related with us, but it is having its own predictions in mathematical way. The immune system evolves to recognize the exact nature of an invader and to counterbalance it. But if the virus keeps on changing, it escapes the defensive system. That's what I was telling. The mathematical models of distributions of virus strains are called quasi-species. They have shown the existence of the mutation rate threshold. But remember, the mutations of the viruses, again, they depend upon the food material which is available to them. And the food material is available only through the host. So in one way or in an indirect way, the hosts are also controlling this mutation. And because of that, there is a control over this. I will just take a moment. Hello. हाँ भाई नमस्कार. हाँ हाँ ठीक है ठीक आहे ठीक आहे चालतंय. मी 5 मिनिटात फोन करतो भाई. मी का मीटिंग मध्ये 5 मिनिटात फोन करतो. So what I was telling you, that the mutation which is taking place, it is taking place not only in the viruses also, but the mutation is taking place even the host also. And so obviously here again the rule of that population dynamics follows, and here we have to understand that who is more infectious. And generally the RNA based viruses, they are more efficient in mutating than the DNA viruses. In developmental biology, we have to go one step ahead. The elegant extensions of the models have been proposed to explain the multiple examples of morphological pattern formation in the development, such as pigmentation in the coat of some mammals. It means when the morphological architecture is being designed, there are 3 bases. One is the protection, second is the food formation, and third is relevance to its nature. And because of that, the mathematical formulations, they are playing a great role in getting the shape of the animals and even in plants also. So there are several animals and plants where you can see they can have a camouflagic effect among each other. Now you can see this. Now I have shown some of the examples. You can see the snakes, tigers, insects. They are taking the shape of their nature, their habitat. So you can see that the habitat and their own skin shape is almost equal in their own protection. On the contrary, the predators, they are having their another mechanism to identify such a camouflage so that they can find their food. A computer software based on the mathematical algorithms has always been used to represent the complex data such as the human genome, that we are talking about the genomics now. And genomics means when our body is having thousands of genes, obviously these thousands of genes, if it are to be understood at a proper location, it is beyond the capacity of a common man. And for that purpose, what we use is a computers. A full genome is like a text with millions of letters, and one cannot just plot this huge amount of gross information. And for that purpose, we have to take the help of a computer, and obviously we have to take the help of the mathematics. The new generation computers with an increasing power can eventually simulate the dynamics of these extremely rich species. Now there is another way. Now I am coming to the last phase of my discussion. Here we are using again the mathematics to understand the age of the earth and age of the evolution of the biological world. Now we are using the parental radioisotopes like uranium, thorium, or potassium, rubidium, smithsonian, or even what we know as a radioactive carbon. And when we use these, we know their half-life period. That is, they are taking the radiation, and through the radiation, they are giving out the energy. And in this way, they are decreasing in their atomic number, atomic mass. And that's why it's called a half-life period. And by calculating this, we can definitely, just like a quasi and quantum clock, we can identify the age. So this is one of the important parameters of using the mathematics in understanding the progress and process of evolution of evolution. With this only, we could understand how the earth has evolved and how even the different epochs have taken place. And so the fossil records, to understand their age, we require these mathematical assumptions. And this is the formula where Y is nothing but it's the radioactive material which is available. It is the material which is available at the present and the material which was present at the beginning. So it's a half-life material, and the ratio between the two is going to give you a formula. It is going to give you the number of years it has taken to get deteriorated. So evolution takes place through the minor changes of a conserved developed program. The multiple examples of the pattern formation in the development, such as pigmentation in the coat of a mammals, the flower shape and the color, which is complementing with the pollinating vectors, that is insects. So we know that during the course of evolution, for the pollination of the flowers, for the dispersal of the fruits and seeds, and even for the germination, they are using the environment. And that's why there is a lot of modifications which are taking place in the fruits and seeds, and also modifications are taking place in the flowers for going ahead with the effective cross-pollination. And this is based on obviously on morphological architecture. Again, the same figure I have repeated here, where you can see that such a type of genetic equilibrium is playing a great role in development of ecosystem and development of a new species in the given habitat. And then it was a very interesting formula which was given by Paul Drake, a British astronomer in 1962. What he had predicted in 1960s, he said that using this formula, we can assume how many civilizations will be available in the universe. And for that purpose, he used this formula. N is equal to, what is the N now? The N is nothing but it is a number of civilizations in our galaxy in which the communication is possible. Because now the astronomers and all the scientists, they were trying to figure out if at all we are alone in the universe or we are having some other extraterrestrial life. And to understand this, he has prepared this formula, he gave this formula. And what this formula says, the number of civilizations in our galaxy is equal to the average rate of star formation per year in our galaxy into the fraction of those stars which are having the only planets into the average number of those planets which may develop an ecosystem. That is, they are present in the green belt, green zone of adaptability of the evolution. Then the fraction of those planets who actually succeed in developing the life. Because even though they are present in the green belt, because in our solar system also, the Mars and Venus, they are present in these margins or the borders of the green belt, but unfortunately there is no life on it. So the fraction of life which is developing the life, then into the fraction of those planets with life that develop the intelligent life like us, because mere simple life is not enough. It has to have a level of integrity. Then the fraction of those planets with the intelligent life which are having a capacity to develop the interstellar communication. So not only intelligence is enough, but they are also requiring a capability to communicate with others. And then the average life of the time of such a civilization to survive and to continue to send the communications. Because ultimately, even how much life it is supposed to take and to survive. For example, on Earth, now we have taken about 4.5 billion years to come to this stage. Now, this development of the human being, it has taken place in just last 10,000 years. But unfortunately, the way of geological changes which are taking place, our Earth may not sustain for next 2 or 10 million years. Will be extinct, will be removed from the Earth. So that component also is equally important. And so this formula, when it was derived in 1960s, almost more than a dozen astronomers, they used this formula and they predicted that ultimately we are not alone on the universe, but there are almost more than thousands of civilizations, they must be existing in our galaxy. But dear friends, in 21st century, with so much impetus of research and technology we are having, unfortunately, even today, we know that more than 3,800 exoplanets, they have been reported, they have been identified by we people. But unfortunately today, even not a single example of communication has been established with conformity. So this is a question, this is a dogma of whether the life what we have received is a unique in the universe or it is having a repetitive form. And all these predictions, if at all we just say in the words, they will become a fairy tale. एक परिकथा होऊ शकेल, नुसती गोष्ट होऊ शकेल. But if at all we want to put it in the scientific formulations, obviously we have to take the help and we have to take the cooperation hand of mathematics. And that's why, from my point of view, biology is incomplete without mathematics, and mathematics merely is only the numbers till we won't take the cases from the biological life. And that's why mathematics and obviously biology both are incomplete without each other. So the same formula I had put in the figures, ultimately these different functions we use from the mathematics. Now we are using the functions, derivatives, trigonometric mathematics, integration, probability. We are using the variables, differential equations, vectors and matrix. All these different forms of mathematics we are using to understand the biology. But there is another branch of prediction, and that is finding the correlation of the large number of population and identifying its interpretation and analysis and correlation. And that is nothing but the statistics, which is known as the predictive mathematics. And these are the different forms of statistical tools we use to understand the biology. These are nothing but the sampling, central tendency, dispersion, deviance, variance and mean deviations, probability, predictions, obviously the correlation, regression, hypothesis testing. Obviously, it is the chi-square test or t-test and so on and so forth. And then experimental design, where we determine the parent and we determine the variant and we try to go for combinations and identify the analysis of their interrelation to each other. That is called the experimental design. And with using these tools from mathematics and statistics, we always try to understand biology in a more and more better way. Working together, the biologists and the mathematicians can contribute more to science than either group can contribute separately. And because of that, dear friends, all this you can see, I am showing a cell, I am showing a development of a fern, I am showing a flower of a sun, which was present. So this was the fossil first life, which was existing 3.7 million years ago. And then we are seeing the galaxies which are following the same pattern of Fibonacci number. So obviously the biology is nothing but the mathematics, and the mathematics is nothing but the biology. So when the biology is present, if we want to put it in a quantified fashion, we take the help of the numbers, and we will have the numbers, and if we want to know its expression, it is nothing but it's a biology. So biology and mathematics, dear friends, they are nothing but they are the two versions, two approaches, two roads of understanding the truth, understanding ourselves, and understanding life. This is a very interesting example that the earth is revolving around the sun and the Venus is revolving around the sun, and we get this picture. So this picture shows that ultimately mathematics is not merely a number, but it is a beauty, and the beauty is present around us. To thank Honorable Kenga sir for giving me an opportunity to interact with you. I thank Kirtane ma'am, I thank IQSC team and the Department of Botany of Yashwanta Savan College of Science, Karat. And I also deeply indebted to the team of this college for inviting me and giving me a time to share my views in online national webinar on sustainability development science, a multidisciplinary approach. And I just wanted to give you the glimpse of these both roads, and I feel that yes, a lot of can be done by the biologists to go ahead and enrich our knowledge. Thank you. Thanks a lot. And I take a break for this presentation. Thank you.
Excuse me, I would like to comment.
Yes, please, sir.
Very interesting and a very informative lecture. Thank you very much, Dr. Chandrasekhar.
Thank you, sir. Thank you, sir.
You have correlated mathematics and biology, especially genetics, in a very good style.
Thank you, sir.
And you also spoke about Mendel. I think Mendel was successful only because he was a mathematician as well as biologist.
Yes, that's true, sir. That's true.
So
That's true.
we must share.
Absolutely.
Must share. Math is very essential for biology.
Absolutely.
To predict something.
Absolutely.
I also know something about statistic because I am a man of
It's
genetics.
very interesting now.
So I
Thank you, sir.
understand it.
Thank you, sir.
Once
I'm honored.
again, thank you very much. Thank you very much.
Thank you, sir. Thank you.
Very much. Very informative.
Thank you, sir. Thank you. I'm honored. Thank you, sir. Please.
Thank you, sir, for sharing valuable experiences in very interesting topic. Thank you, sir. I will go ahead. It is a platform free for the participant to ask their queries.
Kirtana, ma'am.
Yes, sir.
Now, I feel that you should give an opportunity to the next speaker
Okay, sir.
because he'll be waiting. If at all there are any questions, they can email me. You can email me.
Okay.
So I can answer.
Okay, sir. Okay, sir.
Because already we have started 1 hour late.
Yeah.
And Dr. Meena is waiting eagerly
Okay.
to share his views and
Yes, sir.
ideas.
Now, may I request you, Ms. PM Ghadge ma'am, for giving introduction of Honorable Speaker Dr. Bharat Lal Meena sir, Assistant Professor, University of Rajasthan, Jaipur. Please, ma'am.
Thank you, ma'am. Thank you, ma'am. We are very lucky that all three gold medalist personalities are with us today. Now, I would like to introduce our next eminent speaker of today's session, Professor Dr. Bharat Lal Meena, Assistant Professor, Department of Physics, University of Rajasthan, Jaipur, Rajasthan, India. He has PhD from IIT Kanpur in 2010. About his awards, Best Paper Presentation Award, International Conference on Fight Against Cancer in 2017, and he has got a third prize, Gandhian Young Technological Innovation Award in 2016, and the Best Poster Award in International Conference on Light Quanta, Modern Perspectives and Applications in 2015, organized at Allahabad University, Allahabad, India. CSIR Junior Research Fellowship in 2010 to 2012, CSIR Senior Research Fellowship in the period of 2012 to 2013, Graduate Aptitude Test in Engineering GATE, that is GATE, in 2010, Joint Entrance Screening Test in 2010. Then his area of specialization and interest are biophotonics, diagnosis of cancer at early stage. He has contributing a research work in the area of biophotonics, attempting to understand tissue fluorescence and light scanning in human tissues, environment, and to evaluate its use for diagnosis of pre-cancer. He has recently focused on development of portable devices for detection of cervical cancer at early stage using a polarized light. Then he is a member of Technical Societies of Optical Society of America, OSA, and Society of Photo-Optical Instrumentation Engineering, SPIE. Then he has one research project of 15 lakh sponsored by SRISTI on his honor. He is our honorable, that excellent, eminent, knowledgeable personality today with us, with us. And then I hand over the charge for our next speaker, Dr. Bharatlal Meena. To share his knowledge to our dignitaries. Please, sir.
Thank you very much. Good morning, all. Let me first share my. I hope this is visual to all. First of all, I would like to thank Dr. Kusmaji and all the organizers for the committee for giving me this opportunity to present work that is the early stage diagnosis of cervical cancer using fluorescence spectroscopy in this webinar. Am I audible and visual to all? Please confirm so that I can carry on.
Yes, sir.
Yes, sir.
Little bit. Please please speak much more loudly.
Loud. Okay. So now is it all right?
Okay, sir.
Hello. Okay. All right. So in this talk, I will be talking about the early stage diagnosis of cervical cancer using fluorescence spectroscopy. I will start with this. There is problem in the screen, so just give me a minute, please. Yeah. I'm sorry, give me a minute. So one line is coming there which is blocking the presentation. So looking for a way, how can I remove this? I hope now presentation is still visual, right?
Yes, sir, it is visible.
Sorry for the disturbance. So again, let me start again. That I have divided this presentation in 3 parts, and mainly at the beginning, I will talk about the cervical cancer, and where I will be like starting from the what is the cervix and what are the regions that the cervical cancers might start from that at first place, and what are the conventional techniques which are being used to diagnose the for the diagnosis of cervical cancer. And these conventional techniques are mainly three techniques are there. There are different type of techniques are also there, but like I will be talking about pap smear and colposcopy directed cervical biopsy technique and then histopathology. And then in second part, I will talk about the emerging optical techniques for diagnosis of cervical cancer. So when it comes to the optical techniques, the term which is there is the first thing happen is that you are incidenting light on a tissue, and the light tissue interaction is taking place there. So different type of possibilities are there when light interacts with tissue. So our focus will be on fluorescence spectroscopy. And once we know that these are the optical techniques can be used for the cancer detection, then we need something which is like how what are the parameters which can be extracted and can be used to discriminate different grades of the cancer from normal tissue sample. So we'll talk about that. And then we know that directly from the light matter interactions, we get the some signals, we collect the either spectra or images. Then we analyze them with the help of some multivariate algorithms. And those algorithms help us to extract those parameters. So in this talk, I will be focusing on the intrinsic fluorescence, principal component analysis, and linear discrimination analysis. And these जस्ट ओवरऑल ओवरव्यू दूंगा, इसमें इस तरह का नहीं है कि बहुत ज्यादा कि क्योंकि मुझे जिस तरह से सुषमा जी से बात हुई थी कि अपने ऑडियंस में यूजी प्लस पीजी दोनों स्टूडेंट्स भी इसमें होंगे, सो इट विल नॉट बी लाइक कि स्टूडेंट्स को इतना नहीं होगा. आई विल ट्राई माय बेस्ट टू कम टू दैट लेवल. और आई रिक्वेस्ट ऑल द स्टूडेंट्स दैट प्लीज यदि आपको कोई भी तरह का क्वेश्चन डाउट हो तो उसे नोट डाउन कर लें, या फिर उसी एंड में पूछ सकते हैं, या फिर ना बीच में यदि आपको लगे तो आप बीच में पूछ सकते हैं, नो प्रॉब्लम इन दैट. उसके बाद हम इंट्रिंसिक फ्लोरोसेंस बेस्ड एक पोर्टेबल डिवाइस के बारे में बात करेंगे, जो कि मैंने एक्चुअली अभी मेरा पीएचडी के दौरान मैंने इसको वर्क किया और ये डेवलप किया था ये सिस्टम, जो कि इस टाइम पे हॉस्पिटल में 2 डिफरेंट हॉस्पिटल्स में ये अभी ऑन पेशेंट यूज कर रहे हैं, एक डीएसवीएम मेडिकल कॉलेज कानपुर और एक एम्स भुवनेश्वर में. Or at the end, I will talk about the findings of optical device for the sake of completion of the talk. Like these, इस device के help से इस तरह से हमने data collect किया और इस algorithm को, इन algorithms को use करते हुए इस parameter को से हमने different grades of cancers को discriminate किया. And at the end, I will just give tell you about what are the advantages of optical devices over conventional techniques. Because if we want to use optical techniques, then there are some advantages. That is why we are using it. So what are those? We will talk about. So first of all, let me start with the organ about which we, the cancer about which we were talking here. The cervix is nothing but it is a female organ, and it is as you can see in the zoom the image of this here na, it is located at the end of the vaginal tube and at the opening of the uterus. तो ये बेसिकली डोनट शेप में होता है, और इसमें आप देखेंगे कि with age there are some changes in the cellular in the cells of the this region. और इसमें आप देखेंगे लेफ्ट अपर कॉर्नर जिसका जो कि हम बात कर रहे थे कि सर्विक्स का है, तो इसमें आप सेकंड लेफ्ट अपर लाइन में सेकंड जो इमेज है इसमें आप देखेंगे ये प्री मेनरेचुरल एज पे जब फीमेल है, यानी कि बिफोर फीमेल फर्स्ट menstrual cycle, you will see that there are some cells which are called columnar epithelial cells, जो कि इंडोसर्विक सेल है, जो कि इनसाइड आपका जो एक कैनल जो बना होता है, जो ट्यूब है जो कि वेजिनल ट्यूब के एंड से स्टार्ट हो गए यूट्रस में ओपन होता है, तो उसके बीच का जो पोर्शन है उसमें ये कॉलमनार एपिथेलियल सेल्स होते हैं, और जो कि यहाँ पर ग्रे कलर से दिखा रखा है। और एक इसमें स्क्वामस एपिथेलियल सेल्स होता है जो कि आउटर साइड में रहता है, जो कि वेजिनल एनवायरनमेंट से डायरेक्टली कांटेक्ट में रहता है। तो जैसे इसका एज बढ़ता है, जब वो अर्ली रिप्रोडक्टिव एज में है, उस टाइम पर जो कॉलमनार सेल्स है ये धीरे धीरे बाहर की तरफ आने लगती है। तो हम देखते हैं कि जो स्क्वामस कॉलमनार जंक्शन पॉइंट जो था वो अभी धीरे धीरे बाहर की तरफ आने लगता है। तो आप देखोगे कि ये जब अब, क्योंकि कॉलमनार एपिथेलियल सेल्स है, दे आर वेरी मच हैबिचुअल इन द, दे लिव इन द इनसाइड द कैनल, तो बेसिकली उनका एक कॉम्पैक्ट एनवायरनमेंट में रहते हैं, वो दे आर नॉट हैबिचुअल इन लिविंग आउटसाइड द कैनल। सो अब जैसे ही कॉलमनार सेल्स आउटसाइड आएगी तो ये स्क्वामस सेल्स इनको रिप्लेस करेगा। तो लेफ्ट लोअर कॉर्नर में आप देखेंगे कि जब women in her 30s, at that time these cells, columnar cells, the squamous cells start replacing the columnar cells. So the blue region है, ये वाला blue region वो region है जिसमें ये transformation is taking place. So this transformation, the region where this transformation is taking place is called transformation zone. So, but at the next figure, you will see that there are some different stages, like from pre-menopause and post-menopause. At that time, this new squamous columnar junction starts going inside again. But when you see the motivation behind talking about these different the change of the cells at different ages is because there is this transformation zone is the area which is very much vulnerable to the external factors like HPV infection, and which are like cancer causing agents. तो जब आपका ये ट्रांसफॉर्मेशन जोन में किसी भी तरह का एचपीवी इन्फेक्शन, मेनली एचपीवी 16 and 18, वो there are so many type of more than 150 type of HPV infections are there, but few HPV infections are there, they are cancer causing agents. So almost हर सर्वाइकल कैंसर ट्रांसफॉर्मेशन जोन से ही जनरेट स्टार्ट होता है। तो ये जो ब्लू कलर है, ब्लू कलर में जिस सेल्स को दिखा रखा है, ये वो एरिया है जिसमें आपका मैक्सिमम प्रोबेबिलिटी होता है कैंसर स्टार्ट। तो यदि मैं एक WHO की बुक से मैंने फोटो लिया है, इस फोटो में भी हम देख सकते हैं कि ये जो राइट साइड वाला फोटो है, इसमें ही जो व्हाइट पिंकिश कलर का जो एरिया है, ये ट्रांसफॉर्मेशन जोन, और आउटसाइड जो आउटर लाइन बनी हुई है पिंक कलर में, ये हमारा जो ओरिजिनल स्क्वामस एपिथेलियल सेल्स हैं वो है। तो इस तरह से हम देखते हैं कि मैक्सिमम टाइम जो ये जो पिंकिश वाइट जो एरिया है, इस एरिया में कैंसर स्टार्ट होता है। तो आज करंटली जो स्टेटस है इस कैंसर का, वो ये कि देखेंगे कि डेवलपिंग कंट्रीज में almost 9 out of 10 deaths because of cervical cancer are happening. Why? Because of the lack of the facilities. जो फैसिलिटी की कमी की वजह से हम उनको अर्ली स्टेज में डिटेक्ट नहीं कर पाते हैं, और उस वजह से हम क्योंकि कैंसर यदि आप अर्ली स्टेज में डिटेक्ट कर लेते हैं तो उसको आप इजीली क्योर कर सकते हैं। तो इंडिया में भी आप एक स्टैटिस्टिक्स देखें तो ऑलमोस्ट 50% पॉपुलेशन जो सर्वाइकल कैंसर जिनमें डिटेक्ट हुआ है, वो उनका डेथ कॉज होता है। सो यदि हम इस तरह का कुछ करें कि एक कॉस्ट इफेक्टिव इंडिजीनियस टेक्नोलॉजी हम डेवलप कर सकें जो कि कैंसर को अर्ली स्टेज में डिटेक्ट कर सकता है, तो हम इस मॉर्टेलिटी को हम सप्रेस कर सकते हैं। और तो कॉस्ट इफेक्टिव टेक्निक्स और मोर इफेक्टिव टेक्निक्स डेवलप करने के लिए हमने आजकल जो साइंटिस्ट अभी रिसेंटली रिसर्चर्स वर्क कर रहे हैं वो ऑप्टिकल टेक्निक्स डिवाइसेस पे कर रहे हैं, तो उस पे हम डिस्कस करें। उससे पहले जो एट प्रेजेंट कैंसर डिटेक्शन के लिए जो टेक्निक्स यूज की जा रही है, क्योंकि ऑप्टिकल टेक्निक्स आर एट R&D स्टेज, रिसर्च एंड डेवलपमेंट स्टेजेस, most of them. So currently what people are doing is there are three type of conventional techniques they are using. The first stage what they do is they use pap smear technique. उसमें जैसे कार्टून में शो कर रखा है कि फीमेल पे डॉक्टर ओपन फीमेल्स वेजिनल ट्यूब विद द हेल्प ऑफ स्पेकुलम, और एक ब्रश लेते हैं जिस ब्रश से सर्विक्स से वो सेल्स कलेक्ट करते हैं, और उन सेल्स को माइक्रोस्कोप स्लाइड पे स्मीयर करते हैं और उसका माइक्रोस्कोप के अंडर उसको स्टडी करते हैं। यदि ये जो रिजल्ट्स हैं ये किसी भी तरह की इनमें एबनॉर्मलिटी पाई जाती है तो डॉक्टर कहते हैं कि इसका कॉल्पोस्कोपी टेस्ट किया जाए, और कॉल्पोस्कोपी टेस्ट में अगेन फीमेल का जो वेजिनल ट्यूब को स्पेकुला से ओपन करके और फिर उसमें मैग्निफिकेशन लेंस से उसका बिग स्क्रीन पे उसको स्टडी किया जाता है, और फिर देखा जाता है कि यदि किसी भी तरह की एबनॉर्मलिटी यहाँ पे है या नहीं है, यदि है तो किस एरिया में है, दे डिफाइन दैट एरिया, और यदि एबनॉर्मलिटी है तो वो उस एरिया में बायोप्सी करते हैं। बायोप्सी इज नथिंग बट जस्ट उस एबनॉर्मल एरिया से एक छोटा सा टिश्यू का हिस्सा काट के और उसको लेबोरेटरी में फर्दर टेस्टिंग के लिए भेज। तो जो नेक्स्ट स्टेज जो टेस्टिंग है उनका वो होता है फाइनल, जो कि वो फाइनल डिसीजन लेते हैं कि ये नॉर्मल है या एबनॉर्मल है, और एबनॉर्मल है तो किस ग्रेड का है, वो है आपका ये हिस्टोपैथोलॉजी रिपोर्ट। और हिस्टोपैथोलॉजी के अकॉर्डिंग वो क्या करते हैं कि इसको टिश्यू का माइक्रोन थिकनेस के स्लाइसेस काटते हैं, उसको माइक्रोस्कोपिक स्लाइड पे रख के एक प्रॉपर स्टेनिंग एक प्रोसेस होता है उनका 24 आवर्स का, मोस्ट लाइक दैट इट गोज थ्रू वैक्स एंड डिफरेंट स्टेनिंग प्रोसेसेस, और उसके बाद उसको वो माइक्रोस्कोप के अंदर स्टडी करते हैं। तो यदि आप ये लेफ्ट अपर कॉर्नर का फिगर देखेंगे जिसमें हिस्टोलॉजी ऑफ CIN1, CIN is nothing but cervical interepithelial neoplasia. 1 is stage 4 pre-cancer stage 1. So if you look at the that slice of the tissue under the microscope, and you see that okay, I will show you next. I think most of the students are familiar with basic biology, but I will just repeat it that in tissue there are different layers like epithelial layer and stroma layer, and both of the layers are separated with vessel layer. So epithelial layer, if this epithelial layer is 1/3 is filled with abnormal cells, तो हम कहते हैं कि ये हमारा ग्रेड 1 प्री कैंसर स्टेज मीन्स CIN1 स्टेज है। और यदि हम इसमें CIN2 वाला जो फिगर है इसे हम देखेंगे तो हम पाएंगे यदि आपका पूरा एपिथेलियम लेयर का 2/3 पोर्शन एबनॉर्मल सेल से यदि भरा हुआ है तो उसे आप CIN2 ग्रेड का आप कहते हैं। और यदि ये एबनॉर्मलिटी आपका थ्रू आउट एपिथेलियम लेयर स्प्रेड होती है तो आप इसको CIN3 कहते हैं, यानी 3rd ग्रेड कहते हैं। और यदि ये कैंसर सेल्स एपिथेलियम लेयर से स्ट्रोमा लेयर में प्रोपेगेट होने लग जाए जहाँ पर ब्लड वेसल्स अदर थिंग्स आर देयर, देन वी कॉल इट कैंसर। Okay, so this was just about the basic introduction of the cervical cancer. That was the first part of the talk. Now moving to second part जहाँ पर हम बात करेंगे emerging optical techniques for diagnosis of cervical cancer. These techniques ये क्यों हम इन टेक्निक्स को आजकल ज्यादा इस पर फोकस है, क्योंकि ये नॉन इन्वेसिव टेक्निक्स है। means the minimum यानी कि आप कहोगे तो क्या minimum trauma to the patient means physically, emotionally, psychologically, because if patient is going through a minor surgery, then also it gives you the other aspects, like if once the biopsy is done, there is a very high probability that cancer will like propagate with very high speed as compared to with earlier. So very non-invasive techniques. These are safe because no need to go for any biopsy or any other thing, and these are inexpensive, means these are cost effective. They do not. Why cost effective? Because once you have those optical techniques ready, then you do not need any specific laboratory facilities for them. They can work at room temperature, and they can be easily made portable so that you can take them one place to another place. And just by setting a proper environment, you can start. You don't need any specific place to perform that experiment. And these are very compact techniques, so and they doesn't depend on the skills of the expert. जैसा कि आप देखेंगे कि है ना पैपिस्मियर, कोल्पोस्कोपी और हिस्टोपैथोलॉजी, उन सब में आप एक एग्जामिनर उसका एक माइक्रोस्कोप के अंदर या फिर है ना मैग्निफिकेशन ग्लास के अंदर, लेंस के अंदर वो करता है, उसको एग्जामिन करता है. तो ये डिपेंड्स ऑन एग्जामिनर्स स्किल ऑल्सो. यदि एग्जामिनर का स्किल इतना strong अच्छा नहीं है, तो that examiner might miss some signature. So but optical techniques will be handled with a compact algorithm and software. तो आपका ये जो एक्सपर्ट के स्किल पे जो डिपेंडेंसी है, ये आप इसको ऑलरेडी मिनिमाइज कर चुके होते हैं. So basically these optical techniques are capable of extracting diagnostically relevant structural and biochemical information. So let me start with the light tissue interaction. So when हम जानते हैं कि जब light tissue पे incident होगी, तो वहाँ पर mainly 4 type of phenomena might occur. Transmitted, light will get transmitted, light might get reflected, light might get absorbed, and light might get scattered. So हम इस फिगर में देखेंगे कि जब लाइट इंसिडेंट होगा तो आपके स्कैटरिंग हो सकती है, फ्लोरोसेंस हो सकता है, रमन सिग्नल आपको मिल सकता है. यदि लाइट ज्यादा डीप उसमें प्रोपेगेट करती है आपके टिश्यू में, तो एब्जॉर्प्शन हो सकता है, और स्कैटरिंग की वजह से आपका लाइट डिफरेंट पाथ फॉलो करते हुए आइदर ट्रांसमिट भी हो सकता है और वापस आके वो रिफ्लेक्ट भी हो सकता है. और इसमें जैसा कि टॉप लेयर जो जिस एक कलर से दिखा है, ये एपिथेलियल लेयर है, और इसके नीचे स्ट्रोमा लेयर है, और इन दोनों के बीच में एक जो लाइन है, ये बेसमेंट मेम्ब्रेन है, जिसकी हेल्प से आपका ये एपिथेलियल और स्ट्रोमा लेयर है, ये दोनों सेपरेट. तो जब ये लाइट इंसिडेंट होता है, तो ये डिफरेंट जो इंटरफेस होता है डिफरेंट मीडियम से, उनसे पार्शियल रिफ्लेक्शन पे भी जाएगा, और व्हेन ये प्रोपेगेट करेगा तो एब्जॉर्प्शन, स्कैटरिंग, ये सारे फेनोमेना होने से आपको एब्जॉर्प्शन माइट गिव यू लाइक आपका फोटोन है वो पूरी तरह से वेनिश हो गया, या फिर यदि आपका फोटोन ऐसे मॉलिक्यूल के द्वारा एब्जॉर्ब किया गया है जो कि फ्लोरोफोर है, देन यू विल गेट फ्लोरोसेंस सिग्नल. एंड एक ऐसा भी हो सकता है कि आपका लाइट जस्ट फॉल हुआ, एंड बिकॉज ऑफ द चेंज इन द मीडियम, रिफ्रैक्टिव इंडेक्स डिफरेंट होने की वजह से वो स्कैटरिंग होगा और जस्ट आपको स्कैटरिंग सिग्नल्स मिलेगा. तो आप ऑप्टिकल टेक्निक्स जनरली जो यूज कर सकते हैं, फ्लोरोसेंस स्पेक्ट्रोस्कोपी, फ्लोरोसेंस इमेजिंग, रमन स्पेक्ट्रोस्कोपी, इलास्टिक स्कैटरिंग स्पेक्ट्रोस्कोपी, ये डिफरेंट टाइप ऑफ टेक्निक्स है जो कि रिसर्चर्स यूज कर रहे हैं. लेकिन हम इस पर्टिकुलर टॉक में हम फ्लोरोसेंस स्पेक्ट्रोस्कोपी पे फोकस रखेंगे. तो बिफोर दैट हम देख सकते हैं कि जब आपका लाइव टिश्यू पे जो अपना टिश्यू है, लाइव टिश्यू इंटरेक्शन होगा, तो टिश्यू के अंदर कुछ एब्जॉर्बर्स हैं और स्कैटरर्स भी है। तो स्कैटरिंग और एब्जॉर्प्शन बोथ आर वेवलेंथ डिपेंडेंट फेनोमेना। तो जब आपका यदि स्कैटरर्स का साइज आपका थोड़ा लार्ज है, देन इसका जो स्कैटरिंग फेनोमेना एक्सप्लेन करता है वो मीच थ्योरी से किया जाता है, और यदि स्मॉल पार्टिकल्स है तो आप इसको रिले थ्योरी से एक्सप्लेन करता है। और इसका जो मेनली जो आप हम जिस रीजन फ्लोरोसेंस स्पेक्ट्रोस्कोपी मेजरमेंट्स के लिए जिस रीजन में हम फोकस करते हैं वो हमारा होता है यूवी विजुअल रीजन होता है, जिसमें मेनली आपका प्रोटीन, कोएंजाइम्स, हीमोग्लोबिन एंड वाटर एब्जॉर्बर होता है, जो कि आपको कुछ प्रोटीन्स, कोएंजाइम्स वगैरह आपका फ्लोरोफोर्स भी होता है। तो फ्लोरोसेंस क्या फेनोमेना है जिसको हम किस तरह से उसे हम यूज कर सकते हैं इस डिफरेंट ग्रेड्स को नॉर्मल से डिस्क्रिमिनेट करने से। उससे पहले हम बेसिक फेनोमेना डिस्कस करेंगे। तो यदि किसी भी सैंपल पे, इस केस में अपना टिश्यू है, तो टिश्यू पे जब लाइट गिर फॉल होगा तो तुरंत जो कि आपका ग्राउंड स्टेट में जो मॉलिक्यूल्स है वो उसे एब्जॉर्ब करेंगे और एक्साइट स्टेट में जाएंगे। और एक्साइट स्टेट में जो फर्स्ट एक्साइटेड स्टेट है उसके लोएस्ट, यदि आप फिजिक्स बैकग्राउंड स्टूडेंट, फिजिक्स एंड केमिस्ट्री, आई थिंक दोस पीपल विल नो that there are different energy levels, like electronic energy levels are there, and electronic levels के अंदर vibrational levels भी होते हैं। तो आप देखेंगे कि जैसे आपका एटम यदि लाइट एब्जॉर्ब करके एक्साइटेड स्टेट में जाता है तो वहां पर वो फर्स्ट एक्साइटेड स्टेट है उससे वो वापस ग्राउंड स्टेट पे आए, क्योंकि कोई भी एटम है वो एक्साइटेड स्टेट में फॉरएवर रह नहीं सकता, उसे वो वापस ग्राउंड लेवल में आने की कोशिश करेगा। तो जब वो वापस ग्राउंड लेवल में आएगा तो वो आपको जिस वेवलेंथ का फोटोन वो एब्जॉर्ब करता है उससे हायर वेवलेंथ का फोटोन वो इमिट करता है, और उस जो फोटोन है उसका एक पर्टिकुलर वेवलेंथ बजाय एक बैंड आपको मिलता है, एक स्पेक्ट्रम मिलता है, और उस स्पेक्ट्रम को आप फ्लोरोसेंस कहते हैं। और इस फ्लोरोसेंस फेनोमेना के अलावा भी इस प्रोसेस में डिफरेंट फेनोमेना माइट हैपन, लाइक इफ योर एटम इज in the second excited state, let's say, then it has to come to the first lowest vibrational level of first excited state. Sorry. And the process by which it comes to the first excited state, that is called internal conversion. It doesn't give you any kind of photons. Sometimes it might happen that when your atom is in excited state, it might go through the different scattering processes, it might interact with different molecules, or then it might flip its spin. So it will go to the inter-system crossing process, and when it will come to the ground level, then it will give us phosphorescence signal. So mainly what we will be focusing on is the line which is shown by green light, green color, that is fluorescence signal. So in fluorescence signal, once your atom is at excited level state, it is coming back to the ground level and you are getting fluorescence. But you can get fluorescence signal through two processes. One, either you target fluorophore molecule which is there in tissue, or you introduce an actional contrast element which will give you the fluorescence. So basically, but right now in this study, what we did, we used the native fluorophore molecules. We did not introduce any kind of actional fluorophore. जो भी नेटिव फ्लोरोफोर्स है जो ऑलरेडी हमारे टिश्यू में है उसका हमने यूज किया। तो उसे देखेंगे कि ये जो ग्राफ है इससे आप देख सकते हैं कि जो सॉलिड लाइन जो दिखा रहा है, ये सॉलिड लाइन डिफरेंट जो फ्लोरोफोर्स है, जैसे NADH, निकोटिनेमाइड एडेनिन डाइन्यूक्लियोटाइड, फ्लेविन फ्लेविन एडेनिन डाइन्यूक्लियोटाइड, और पॉर्फिरिन, ये मेनली आपके these elastin also, that collagen and elastin also there. तो अब ये डॉटेड आप स्पेक्ट्रा देखेंगे तो ये इन्फ्लोरोसेंस स्पेक्ट्रा है। तो आप देखेंगे कि ना हर एक उसका इस टेबल में देख सकते हैं लेफ्ट लोअर कॉर्नर में कि जो भी फ्लोरोफोर है उसका एक पर्टिकुलर एब्जॉर्प्शन पीक है और उस एब्जॉर्प्शन पीक से फ्लोरोसेंस फोटोन को एब्जॉर्ब करके एक्साइटेड स्टेट में जाते हैं और हायर वेवलेंथ पे ये जो आपको इमिशन पीक देगा। और ये जो डिफरेंस है एब्जॉर्प्शन एंड इमिशन मैक्सिमा का, इसको हम स्टॉक शिफ्ट कहते हैं। वो अभी यदि इससे कंफ्यूज होने की जरूरत नहीं स्टॉक शिफ्ट का हो, यहाँ पे जस्ट हमें ये चीज देखना है कि when light is falling on sample, it is getting absorbed by the native fluorophores, they are giving us fluorescence. So now, all right, we know that these are the fluorophores inside the tissue, but can we use them for to extract some useful information? Yes, we can. If you are talking about the steady state fluorescence spectra, then we can just talk about the quantum yield, like you are getting the fluorescence signal, and since the fluorescence signal, when this light matter interaction happens, then there might be some non-radiative transition. So radiative transition and non-radiative transition both will be there. But if you want something very significant signal, then you want that the radiative transition should dominate. So you use that to calculate the quantum yield, like radiative transition divided by total transition possibility, means radiative plus non-radiative transition. We can also use the concentration as one of the parameters. We can use spectral line shape as another one of the parameters. And in this, at the end of the presentation, I will show you that how we use the concentration as a parameter for the discrimination of different grades. And if you are working with lifetime fluorescence spectroscopy or fluorescence imaging microscopy, then you can use the lifetime phenomena or lifetime also as a diagnostic parameter. But in this talk, at the end, I will focus on the how we use the concentration as a parameter to discriminate the different grades of the cancers from normal. So if you look at the biochemical aspect, basically what happens, the fluorescence tells you about the biochemical changes which are happening inside the tissue. So I think all botany and zoology people know all well about very nicely about the Krebs cycle. And here what I want to point out is that when this Krebs cycle starts, there are some fluorophores like coenzymes are there, like NADH, FAD, FMN. So they, if you talk about NADH, then this NADH, if your sample is abnormal, then this cycle rate will also change. So if the cycle rate is changing, then your NAD plus is continuously converting in NADH. It's in its reduced form, that is NADH. And you see that NAD plus does not give you fluorescence, but NADH gives you fluorescence. So when you talk about the metabolic process, some reactions which are happening in this metabolic pathway, then you can easily say that if your NADH signal is increasing, then you can say that some abnormality is happening there. And if you want to talk about FAD, then FAD converts to FADH, this reduced form, and FADH does not give you fluorescence. So FAD plus gives you fluorescence, but FADH does not give you fluorescence. So as this cycle goes on, then your fluorescence signal from FAD get decreased. And if your abnormality is such that it reaches to this structural proteins, means the stromal layer, then there is a collision cross-links are there, and they will get broken because of these abnormalities. So you will see that fluorescence signals are again changed because of those abnormalities. So basically, these you can easily use these coenzymes and structural proteins as a marker, and you can work on that, and you can say that these are the ways we can discriminate different grades of cancer. So now, till this point, what I was trying to tell you is कि ना हमारे पास में यदि आपका लाइट टिश्यू पे इंटरेक्शन आपका होगा, तो आप देखेंगे कि वहां पर फ्लोरोसेंस एक वन ऑफ द फेनोमेनाज है जो कि वहां पर हो सकता है. अब फ्लोरोसेंस में भी, लेकिन अब क्योंकि फ्लोरोसेंस सिग्नल भी आपका मीडियम के टिश्यू के थ्रू ही प्रोपेगेट करके आएगा, और आप ये जानते हैं कि टिश्यू एक टर्बिड मीडियम है. अब टर्बिड मीडियम विच कंटेन्स एब्जॉर्बर्स एंड स्कैटरर, और यदि आपका फ्लोरोसेंस सिग्नल एक स्कैटरर्स और एब्जॉर्बर्स के बीच से प्रोपेगेट होके आएगा, तो इनका जो सिग्नल, जो फ्लोरोसेंस सिग्नल हमारा जो ओरिजिनल सिग्नल है, वो उसमें कुछ ना कुछ मॉडिफिकेशन जरूर आएगा. तो बेसिकली हमारा जो नेटिव फ्लोरोफोर्स से जो आपका फ्लोरोसेंस सिग्नल था, that is getting affected because of these absorbers and scatters. So एक टेक्निक है जिसमें हम पोलराइज्ड लाइट यूज करते हैं, और उस पोलराइज्ड लाइट का यूज करते हुए स्कैटरिंग और एब्जॉर्प्शन इफेक्ट है उसको हम मिनिमाइज कर सकते हैं. और हम कह सकते हैं कि ये 2013 का एक पेपर है जिसमें ये काफी अच्छे से एक्सप्लेन कर रखा है कि किस तरह से ये मिनिमम इस स्कैटरिंग और एब्जॉर्प्शन इफेक्ट को किस तरह से मिनिमम किया जा सकता है. और इसमें हम क्या करते हैं कि जैसे यदि हम वर्टिकल पोलराइज्ड लाइट, लेट से हम सैंपल पे इंसिडेंट कर रहे हैं, तो ये एक टाइम पे हम कलेक्ट करेंगे वर्टिकल पोलराइज सिग्नल ही पोजीशन. वी आर यूजिंग एन पोलराइजर एंड एन एनालाइजर. So polarizer is setting your light to the vertical polarization position, and with the help of analyzer, हम vertical and horizontal polarization orientation में fix करके और को और cross polarized signal हम collect करते हैं. तो यदि आप को polarized signal हम collect करते हैं टिश्यू से, तो co-polarized means कि जो polarization का state हमने इंसिडेंस किया है उसी पोलराइजेशन स्टेट को हम डिटेक्ट कर रहे हैं. यानी कि इस पर्टिकुलर लाइट का, इस फोटोन का जो स्कैटरिंग की वजह से जो पोलराइजेशन में चेंज आना चाहिए, तो वो इफेक्ट मिनिमम है. तभी हमारा, यानी कि जैसा हमने इंसिडेंस किया वैसा ही हम कलेक्ट कर रहे हैं. तो हम व्हेन यू टॉक अबाउट द को-पोलराइज्ड फ्लोरोसेंस स्पेक्ट्रा, व्हिच आई विल शो यू इन शॉर्टली, उसमें हमारा स्कैटरिंग इफेक्ट बहुत मिनिमम होता है, लेकिन होता जरूर है. उसके बाद में हम क्या करते हैं, यदि आप क्रॉस पोलराइज सिग्नल भी कलेक्ट करते हो, तो हम देखते हैं कि क्योंकि क्रॉस पोलराइज फ्लोरोसेंस मींस यू आर इंसिडेंटिंग वर्टिकल पोलराइज लाइट, बट यू आर कलेक्टिंग द लाइट which has the orientation of the polarization is 90 degrees as with reference to the incident light. So it means your light lost its polarization. That is why you are able to see the horizontal polarized light there. So this cross polarized signal will be affected with because of this scattering very highly. And so if you take the difference of polarized polarized fluorescence spectra and take the polarized fluorescence spectra and subtract the cross polarized fluorescence from this, then you will find that the whatever scattering effect is there, that you are minimizing because a co-polarized signal will have the signal from the top and as well as signal from the depth also. So basically क्रॉस पोलराइजेशन का जो सिग्नल का जो कंपोनेंट है उसके बराबर आपका को-पोलराइज वाले में भी होगा, तो वो एक दूसरे को कैंसिल आउट करेंगे और हमारे पास में सिर्फ इंफॉर्मेशन रहेगी जो कि टॉप लेयर से आई है, जिसमें मैक्सिमम आपका सिग्नल है वो स्कैटरिंग फ्री है. तो बेसिकली डिफ्यूज स्कैटरिंग से हमने इस स्टेज पे हमने मिनिमम कर दिया है. अब यदि मैं एक काम करता हूँ कि व्हाइट लाइट यूज करता हूँ, और व्हाइट लाइट को क्रॉस पोलराइज स्पेक्ट्रा में कलेक्ट करता हूँ स्कैटरिंग सिग्नल, तो उसमें हमारा जो भी सिग्नल हमें शो होगा वो दैट विल बी बिकॉज ऑफ द absorption effect and scattering of course, but by taking the difference of this, use this O minus cross, then you will get rid of the diffuse scattering. So the whatever effect is there, that is absorption effect. So now divide the polarized fluorescence spectra with this absorption spectra, you will get the intrinsic fluorescence spectra. So in short, what I was trying to tell you is कि यदि हमारे पास में फ्लोरोसेंस स्पेक्ट्रा है और तो वो एब्जॉर्प्शन और स्कैटरिंग इफेक्ट्स की वजह से मॉडिफाई हो जाएगा, तो उसे मिनिमाइज करने के लिए हमने एक एल्गोरिदम यूज करी, एक एक्सपेरिमेंटल टेक्निक यूज करी, और वो एक्सपेरिमेंटल टेक्निक में हमने एक पोलराइजर और एक एनालाइजर की हेल्प से को एंड क्रॉस पोलराइज सिग्नल कलेक्ट किए विथ लेजर which gives you fluorescence spectra and with white light source xenon lamp. इस केस में हमने यूज किया, तो xenon lamp से हमें स्कैटरिंग सिग्नल मिला, और इस रेशियो से हमने जो एब्जॉर्प्शन और स्कैटरिंग इफेक्ट था उसको हमने मिनिमम कर दिया, और हमने इंट्रिंसिक फ्लोरोसेंस स्पेक्ट्रा हमने लिया। अब क्योंकि आपके पास जो स्पेक्ट्रा है वो मैक्सिमम उसमें फ्लोरोफोर्स की इंफॉर्मेशन है, स्कैटरर और एब्जॉर्प्शन की बहुत कम है, तो इसको हम नेक्स्ट स्टेज में यूज कर सकते हैं डिफरेंट एल्गोरिदम्स में। और जो इस एल्गोरिदम इसमें यूज करी है मैंने, वो है प्रिंसिपल कंपोनेंट एनालिसिस। इसके काफी स्टेप्स होते हैं, 5-6 स्टेप्स, लेकिन उस स्टेप में जाने के बजाय हम ये कह सकते हैं कि पीसीए को हम यूज करते हैं, एक आपका लार्ज नंबर सेट ऑफ द डेटा हैं आपके, तो उसको हम एक लेस डायमेंशन में आप यदि रिप्रेजेंट करने चाहते हैं विदाउट लूजिंग इन मच इंफॉर्मेशन, मीन्स आपका जो 99.9% इंफॉर्मेशन तो आपका उसमें कंटेंट रहता है, और लेकिन आप उसका डायमेंशन उस लेवल तक रिड्यूस कर देते हैं कि आपका रिप्रेजेंटेशन इज इजी ना। So you use that principal component analysis to represent your data in the less dimension, and you select some of the components, these are called scores, and then I use a linear discrimination analysis as a discriminator. What it does is इसकी हेल्प से हमारा जो सिमिलर जो सिग्नल है उनसे हम जो पैरामीटर्स एक्सट्रैक्ट करते हैं, उन पैरामीटर्स को आप देखते हो कि उन्हें हम कहते हैं, जैसा प्रिंसिपल कंपोनेंट आउटपुट है स्कोर्स। अब इन स्कोर्स को हम एलडीए में इनपुट के तौर पे काम में लेंगे, तो वो आपका जो सिमिलर जो सैंपल है, लेट्स से नॉर्मल सैंपल है, तो नॉर्मल सैंपल के सारे डेटा एक पर्टिकुलर वो पैटर्न फॉलो करेंगे, और एबनॉर्मल है वो दूसरा पैटर्न फॉलो करेंगे। तो नॉर्मल सेम कैटेगरी के जो सैंपल्स है उनका एक उनके बीच का जो वेरिएशन है उससे तो मिनिमाइज करता है, और जो अलग अलग ग्रेड्स के हैं, अलग अलग कैरेक्टरिस्टिक रखने वाले, उन दोनों के बीच का सेपरेशन इंक्रीज करता है। तो बेसिकली व्हाट वी डू इज वी मैक्सिमाइजेस द रेशियो ऑफ द बिटवीन क्लास डिस्टेंस टू विद इन क्लास डिस्टेंस। तो इससे क्या हुआ कि जो डिफरेंट क्लासेस हैं आपके सैंपल्स का, वो एक डिफरेंट क्लस्टर बनाएंगे, और आप इजीली कह सकते हो कि ये क्लस्टर नॉर्मल है, ये एबनॉर्मल है। और यदि आपका जो सैंपल आप देखना चाह रहे हो कि नॉर्मल है या एबनॉर्मल है, और वो जिस क्लस्टर के पास में या जिस क्लस्टर में जाके स्टे करता है, उसे आप उसी ग्रेड का सैंपल कह सकते हो। ये मैं रिजल्ट आपको शो करूंगा बाद में। तो दूसरा जो डिस्क्रिमिनेटर है वो मैंने यूज किया है, इसमें शो करूंगा, वो रिसीवर ऑपरेटिंग कैरेक्टरिस्टिक कर्व्स एनालिसिस। तो इसको मेनली हम आरओसी कर्व एनालिसिस से जानते हैं। इट इज वेरी यूजफुल फॉर ऑर्गेनाइजिंग क्लासिफायर्स एंड विजुअलाइजिंग देयर क्वालिटीज। सो व्हाट वी डू इज दैट इफ यू सी दैट द डॉटेड लाइन दैट इज एट 45 एंगल, तो इस 45 एंगल के एक्स एक्सिस 1 माइनस स्पेसिफिसिटी एंड वाई एक्सिस इज सेंसिटिविटी। बेसिकली सेंसिटिविटी मीन्स आपका कोई भी डिवाइस है वो जिस भी फेनोमेना को आप डिटेक्ट करना चाह रहे हो उसके लिए कितना सेंसिटिव है। मीन्स नॉर्मल है तो उसे किस लेवल कितना परसेंट वो नॉर्मल कह रहा है, और एबनॉर्मल है तो उसको कितना परसेंट वो एबनॉर्मल कह रहा है। और स्पेसिफिसिटी आपका कि 1 माइनस स्पेसिफिसिटी पहली से कि है ना, आप किस तरह से इसका जो फॉल्स पॉजिटिव रेट है तो वो आपका 1 माइनस स्पेसिफिसिटी, क्योंकि कुछ कुछ आपके सैंपल टेस्ट होता है कि जो कोई सैंपल है वो यदि मान लो कि आपका नेगेटिव है लेकिन वो पॉजिटिव ग्रुप में आ रहा है तो वो फॉल्स पॉजिटिव हो गया। तो यदि आप एक्स एक्सिस पे फॉल्स पॉजिटिव और वाई एक्सिस पे ट्रू पॉजिटिव लेते हुए ग्राफ बनाते हैं तो ये जो लेफ्ट अपर कॉर्नर में जो सैंपल आपका आएगा, जो क्लस्टर बनेगा, वो ही आपका बेस्ट डिस्क्रिमिनेटर होगा। ये भी मैं आपको एक एग्जांपल जो हमारे रिजल्ट को देते हुए बताऊंगा तो वहां और क्लियर हो जाएगा आपको। तो मूविंग टू द नेक्स्ट, अब तो ये मैं बेसिक बताना चाह रहा था कि फ्लोरोसेंस स्पेक्ट्रा कलेक्ट करने के बाद में हम कुछ मैथमेटिकल मॉडल्स, कुछ एल्गोरिदम्स यूज करते हुए डिफरेंट ग्रेड्स को हम डिस्क्रिमिनेट कर सकते हैं। तो उस पूरे फिजिकल जो आपका फ्लोरेंस था उसका यूज करते हुए हम कुछ ऑप्टिकल डिवाइसेस हम वो कर फैब्रिकेट कर सकते हैं। बहुत सारे रिसर्चर्स जो रमन स्कैटरिंग बेस्ड फ्लोरोसेंस इमेजिंग, फ्लोरोसेंस स्कैटरिंग, इलास्टिक स्कैटरिंग बेस्ड डिफरेंट टाइप ऑफ सिस्टम्स दे आर डेवलपिंग। तो यहाँ जो मैं शो कर रहा हूँ ये वो है जिसमें मैंने एक इंट्रिंसिक फ्लोरोसेंस बेस्ड इन हाउस फैब्रिकेटेड पोर्टेबल डिवाइस फैब्रिक किया था, जिसको हमने ऑन टेबल स्टार्ट किया था, मींस ओपन सिस्टम से स्टार्ट करके एट प्रेजेंट वी आर यूजिंग इन ऑन द पेशेंट। ये जर्नी काफी खूबसूरत जर्नी से हम गुजरे और काफी अच्छे एक्सपीरियंसेस के थ्रू वो थोड़ा सा मैं आपके साथ एक्सपीरियंस शेयर करूंगा। तो इसमें हम क्या कर रहे हैं कि लेजर लाइट यूज कर रहे हैं, लेजर डायोड लेजर 405 नैनोमीटर जो कि आपका फ्लोरोसेंस देता है। तो 405 नैनोमीटर पे जैसा आपने नोटिस किया होगा उस ग्राफ में एफएडी आपका डोमिनेटिंग फ्लोरोफोर है और एक हम व्हाइट लाइट सोर्स के रूप में जीनोन लैंप यूज कर रहे हैं। तो ये डिफरेंट ऑप्टिकल कंपोनेंट से होते हुए लाइट सैंपल पे गिरती है और हम इसको बैक स्कैटरिंग मोड पे डिटेक्टर से मिनिएचर स्पेक्ट्रोमीटर से कलेक्ट कर सकते हैं। तो ए स्पेक्ट्रा है ये जो ब्लॉक डायग्राम रिप्रेजेंट कर रहा है। बी आपका ओवरऑल कॉम्पैक्ट सिस्टम जो हमने डेवलप किया था उसका एक कार्टून रिप्रेजेंटेशन है। और जो लेफ्ट लोअर कॉर्नर में जो सी फिगर है ये आपको लाइव जो एक्सपेरिमेंट हम कर रहे हैं टोटल स्ट्रेक्टमी सैंपल। टोटल स्ट्रेक्टमी सैंपल बेसिकली जिसमें डॉक्टर्स क्या करते हैं फीमेल का पूरा यूट्रस ही रिमूव करके और उसको बायोप्सी या फर्दर स्टडीज के लिए भेजते हैं। तो जैसे उसको पैथोलॉजी लैब में भेजते थे उससे पहले हम उसको हमारे ऑप्टिकल डिवाइस पे देखते थे, डेटा कलेक्ट करके और फिर उसको स्टडी करते थे। तो फिगर नंबर डी में आप देखेंगे कि जो हमने ट्रांसफॉर्मेशन जोन की बात करी थी तो वो देखिए जो येलो सर्कल है ये पूरा येलो सर्कल में वो सेंसिटिव जो सेल्स है जो कि है ना ट्रांसफॉर्मेशन से गुजर रही है उनको आप आराम से इजीली स्पॉट कर सकते हो। रेड पैचेस वगैरह इसमें है। तो हम क्या करते थे कि है ना ट्रांसफॉर्मेशन जोन से सिग्नल कलेक्ट करते हैं और आउटर जोन से सिग्नल कलेक्ट करते हैं ताकि ये देख ले कि आउटर जोन में स्प्रेड हुआ है या नहीं हुआ है तो कितना हुआ है, नहीं हुआ है तो वेल एंड गुड है। उसके बाद में हमने इसको ये इस स्लाइड में मैं शो करना चाह रहा था कि जैसे कि आपका ए फिगर में कि कार्टून रिप्रेजेंटेशन है कि हमारा किस तरह से हमने इन विवो डिटेक्शन किया। इन विवो डिटेक्शन बेसिकली डिटेक्ट द डिसीज when you are not removing anything from the patient. Basically in the you are testing your device with patient directly. So this device left lower corner shows figure number C. It is showing that the device is going inside the patient, and then in zoomed 1D part, you can see that the tip of the device is touching the cervix, and it is collecting the signal. तो इस डिवाइस को हमने डेवलप किया और इसे डेवलप करके और हमने टेस्ट किया। तो हमने दो शुरू में क्योंकि इसको आप डायरेक्ट पेशेंट पे यूज नहीं कर सकते तो एक्स विवो स्टडीज किया, यानी कि डॉक्टर हमको एक छोटा सा पोर्शन निकाल के दे देते थे और फिर हम उस पर टेस्ट करते और फिर उस सैंपल को वापस पैथोलॉजी रिपोर्ट में भेज देते हैं। और इसी तरह से हमने इसको स्ट्रेक्टमी सैंपल पे भी किया जिसमें हम डॉक्टर पूरा यूट्रस निकाल के देते उस पर हम सर्विक्स पे टेस्ट करते थे। तो हम एक प्रोटोकॉल फॉलो करते हैं कि यदि कोई भी पेशेंट आता है ओपीडी में तो उसका पेपिस्मियर टेस्ट होगा। यदि वो नॉर्मल है तो कोई टेस्ट नहीं होगा, एबनॉर्मल है तो वो कोल्पोस्कोपी टेस्ट पे जाएगा। यदि कोल्पोस्कोपी टेस्ट आपका नॉर्मल है तो देन पेशेंट के साथ में कुछ फर्दर टेस्ट नहीं होगा। लेकिन यदि एबनॉर्मल है तो उसका बायोप्सी होगा, और यदि वो उस लेवल का एबनॉर्मलिटी आ चुका है कि ना इस पूरे ऑर्गन को रिमूव करना पड़ेगा तो वो स्ट्रेक्टमी पर जाता है। और इस स्टेप के बाद में हम स्पेक्ट्रोस्कोपी मेजरमेंट्स लेते हैं और उस सैंपल को हम हिस्टोपैथोलॉजी में भेज देते हैं। और ये हम एक्स विवो में प्रोटोकॉल फॉलो करते हैं। और इसी तरह से हम जब इन विवो करते थे तो क्योंकि इन विवो आप कर रहे हो जिसमें आप सैंपल रिमूव नहीं कर रहे हो पेशेंट से, तो हम दो तरह के ग्रुप यूज करते हैं। कंट्रोल ग्रुप जिसमें कोई साइन और सिम्टम्स नहीं है तो उसका जस्ट पेपिस्मियर होता है, कोल्पोस्कोपी होता है और स्पेक्ट्रोस्कोपी मेजरमेंट, सो दैट वी नो दैट दीज आर द नॉर्मल पेशेंट। और यदि कोई पेशेंट साइन और सिम्टम्स के साथ आता है उसे हम स्टडी ग्रुप कहते हैं। और सिमिलर टू बायोप्सी प्रोटोकॉल वी फॉलोड द पेपिस्मियर। यदि एबनॉर्मल है तो कोल्पोस्कोप, और कोल्पोस्कोप पॉजिटिव है तो स्टेक्टमी और बायोप्सी होगा और वो पैथोलॉजी होगा। और हम उसमें जो एबनॉर्मल दिखाते हम क्या करते थे, कोल्पोस्कोपी के पैरेलल हम स्पेक्ट्रोस्कोपी मेजरमेंट लेते थे। तो इस प्रोटोकॉल को फॉलो करते हुए हमने स्टडी किया। और अब ये जो कुछ जो 4-5 स्लाइड्स में मैं ये जो ऑप्टिकल डिवाइस है इसकी फाइंडिंग्स के बारे में डिस्कस करूंगा। तो मेन पॉइंट मेरा यहाँ पर जो हाईलाइट करना जो स्पेशली टू फॉर द यूजी स्टूडेंट्स, यूजी एंड पीजी स्टूडेंट्स, की you just have to look at the things which I'm trying to tell you is that if you look at the A spectra, means the left upper corner, it shows the copolarized fluorescence. Same sample, but one signal is from normal and another one is from grade 1 sample. Then you take B, this plot shows the cross-polarized fluorescence. If you will look at it closely, then you will see that the cross-polarized fluorescence is broader than copolarized signal. And you will see at the peak, that is around 520, that is, the dip in the spectra is high in cross-polarized as compared to copolarized. Why? Because the absorption and scattering is dominating in the cross-polarized fluorescence as compared to copolarized fluorescence. So you see the more scattering and absorption effect in the cross-polarized fluorescence spectra. And if you will look at the C spectra, that is in the lower left corner, then you will see that the dips and the broadening is not there. It means that we have minimized the scattering and absorption effect. And if you look at the D spectra, then you can easily see that the intrinsic fluorescence, which is free from the scattering and absorption effect, it can be easily visible in this spectra. Okay, so main motivation behind showing this slide to the UG-PG students is that get a feeling that जब भी हमारा ये जो co-polarized fluorescence spectra है इसमें और क्रॉस पोलराइज स्पेक्ट्रा है, इनमें कुछ स्कैटरिंग एब्जॉर्प्शन इफेक्ट्स आपके इंक्लूड होंगे। और जब आप इन स्कैटरिंग और एब्जॉर्प्शन इफेक्ट्स को आप रिमूव करेंगे तो जो सी स्पेक्ट्रा आप देख रहे हैं जिसमें कि आपका स्कैटरिंग और एब्जॉर्प्शन डिप वहां पर है नहीं आपका, आप पूरी ऑलमोस्ट पूरी तरह से आप उसे एलिमिनेट कर चुके हैं। तो दिस इज द मैथमेटिकल एल्गोरिदम एक्सपेरिमेंटल अप्रोच व्हाट आई वाज टॉकिंग अबाउट कि को एंड क्रॉस पोलराइज्ड फ्लोरोसेंस और इलास्टिक स्कैटरिंग डेटा कलेक्ट करेंगे और फिर उस एल्गोरिदम पे अप्लाई करके हम स्कैटरिंग और एब्जॉर्प्शन इफेक्ट्स को मिनिमाइज करेंगे, जो कि हम सी स्पेक्ट्रा में क्लियरली देख सकते हैं। तो अब ये लेने के बाद में यदि हम डायरेक्ट बात करें कि ओके ये हमारा क्योंकि एफएडी के बारे में आप बात कर रहे हो तो एफएडी का क्या हो रहा है, जैसे आपका एबनॉर्मलिटी इंक्रीज होगा तो फ्लोरोसेंस सिग्नल में का इंटेंसिटी कम होता चला जाएगा। So why not use the concentration directly? But when you see at this scattering spectra, then you see that क्योंकि हर एक पेशेंट का मेटाबॉलिज्म डिफरेंट होता है, तो आप देखोगे कि इसका जो डायरेक्ट जो यदि आप एरिया अंडर द प्लॉट या फिर इंटेंसिटी आप लेने की, इंटेंसिटी बेसिकली आपका एरिया अंडर द एंटायर स्पेक्ट्रा ही होता है, जो कि आपका उसका रिलेटिव कंसंट्रेशन बताते हुए आपको बता देता है कि इसका कितना कंट्रीब्यूशन। तो डायरेक्टली आप यदि कंसंट्रेशन यूज करना चाहेंगे तो आप उसको नहीं कर पाएंगे। क्यों? क्योंकि आप इस प्रीवियस स्लाइड में देखिए कि टेल वाला पार्ट है 600 से 700 नैनोमीटर के बीच में हमको एक छोटा सा एक उभरा हुआ पार्ट और दिख रहा है, दैट इज बिकॉज ऑफ फॉस्फोरिन फ्लोरोसेंस। So fluorescence because of FAD and fluorescence because of porphyrin are both are overlapping here. So what we did was कि हमने एक एल्गोरिदम यूज किया और उसके थ्रू हमने कर्व फिटिंग किया, और कर्व फिटिंग से जो डिफरेंट, यदि एक से ज्यादा फ्लोरोफोर्स का आपको कंट्रीब्यूशन है तो डिफरेंट फ्लोरोफोर्स के उसको कर्व फिटिंग से सेपरेट करो कि कौन से फ्लोरोफोर का कितना कंट्रीब्यूशन है, और जब आप एक फ्लोरोफोर का आप यदि निकाल पाए तब आप क्या करो कि उसी की कंसंट्रेशन के बारे में बात करोगे, तो हो सकता है कि है ना एक अच्छा आपको रिजल्ट मिल जाए। इस होप के साथ में हमने ये किया। तो ये जो अराउंड 500 जो हमें पीक दिख रहा है, जो डॉटेड लाइन है, ये हमारा फिटेड लाइन है एफएडी के लिए। अराउंड 600 जो है ये पॉर्फिरिन के लिए। पॉर्फिरिन के 2 पीक आते हैं, तो मेनली डोमिनेटिंग आपका 600 के आसपास है। तो हमने क्या किया कि ये फिटिंग करके पॉर्फिरिन का जो कंट्रीब्यूशन है उसे सेपरेट किया एफएडी कंट्रीब्यूशन से। फिर हमने सिर्फ एफएडी को लेते हुए और डिस्क्रिमिनेटिंग एनालिसिस करने की कोशिश करें। तो ये जो स्पेक्ट्रा है हमने इंट्रिंसिक फ्लोरोसेंस स्पेक्ट्रा के साथ में किया, और इसको कंपेयर करने के लिए कोर क्रॉस पोलराइज्ड फ्लोरोसेंस के साथ में हमने कोशिश करी, तो वो ये स्पेक्ट्रा है। So you can just look at it, do not worry about it, or like almost similar, just to see that how different fluorophores and different parameters are changing in intrinsic fluorescence, copolarized fluorescence and cross polarized fluorescence. उसके बाद हमने, जैसा कि मैंने बताया, ROC कर्व एनालिसिस यूज किया, और इसमें एरिया अंडर द कर्व डिवाइडेड बाय FWHM पैरामीटर यूज किया, जो कि आपका डिफरेंट वेरिएशंस को मिनिमाइज करते हुए, और बिकॉज कंट्रीब्यूशन बिकॉज ऑफ द फ्लोरोफोर आपको मैक्सिमम हाईलाइट करता है। तो आप देख सकते हैं कि है ना, जो राइट लोअर कॉर्नर में जो डी फिगर है उसमें हमारा जो नॉर्मल वर्सेस ग्रेड 1 है उसका डिस्क्रिमिनेशन थोड़ा पुअर है, लेकिन नॉर्मल वर्सेस ग्रेड 2 एंड नॉर्मल वर्सेस ग्रेड 1 वर्सेस ग्रेड 2 वेरी हाईली डिस्क्रिमिनेट कर सकते हैं हम, हाई सेंसिटिविटी और स्पेसिफिसिटी के साथ। अब क्योंकि नॉर्मल और ग्रेड 1 है, प्री कैंसर ग्रेड 1, इन दोनों के जो बायोकेमिकल चेंजेस है वो रिवर्सिबल है। वो ऐसा है कि है ना, यदि बहुत सारे ऐसे चेंजेस हैं जो यदि आप ग्रेड 1 पे देखते हैं तो वो नॉर्मल भी वो कन्वर्ट हो सकते हैं, बट इसलिए मे बी वन ऑफ द रीजंस की है ना, आपका नॉर्मल और ग्रेड 1 को आप इतने हाई सेंसिटिविटी स्पेसिफिसिटी से डिस्क्रिमिनेट नहीं कर पा रहे हैं, लेकिन हायर ग्रेड्स को हम बहुत अच्छे से डिस्क्रिमिनेट कर पा रहे हैं। इसी तरह हमने कोपोलराइज्ड फ्लोरोसेंस को लिया, क्रॉस पोलराइज को किया, और फिर देखा कि जो बेस्ट जो डिस्क्रिमिनेशन है वो हमारा इंट्रिंसिक फ्लोरोसेंस से हम कर पाए। और उसके बाद में हमने दूसरा जो प्रिंसिपल कंपोनेंट एनालिसिस था उसे भी यूज करके देखा कि हमारा प्रिंसिपल कंपोनेंट एनालिसिस से, तो इसमें देखा कि हमारा जो फर्स्ट 7 स्कोर है उन्हें यदि हम सेलेक्ट करते हैं तो अराउंड 99% हमारा डेटा का इंफॉर्मेशन कंटेन कर लेते हैं। और फिर ये क्रॉस वेरीफाई करने के लिए कि हमारा वाकई ये चीज इतना इंफॉर्मेशन कंटेन करता है या नहीं करता है, तो हमने क्या किया कि जस्ट रिवर्स एल्गोरिदम किया, और जो ओरिजिनल स्पेक्ट्रा था उससे इसको मैच कंपेयर किया, तो देखा कि ओरिजिनल और रिकंस्ट्रक्टेड जो डेटा थे वो ऑलमोस्ट सेम थे। तो बेसिकली मैक्सिमम इंफॉर्मेशन हमारी प्रिजर्व थी। फिर ये स्कोर सेलेक्ट करते हुए हमने LDA यूज किया, लीनियर डिस्क्रिमिनेशन एनालिसिस, और उससे आप इसमें देख सकते हैं कि नॉर्मल, ग्रेड 1, ग्रेड 2 तीनों के डिफरेंट क्लस्टर बने हुए हैं, और आप इजीली इनको सेपरेट, और आप देखेंगे कि नॉर्मल और ग्रेड 1 को 97% सेंसिटिविटी और 98.5% स्पेसिफिसिटी से हम डिस्क्रिमिनेट कर पाए थे, जो कि काफी सही था। और उसके बाद में मैं लास्ट में इसको समराइज करने से पहले यदि ओवरऑल हम देखना चाहे कि ऐसा ये जो कन्वेंशनल टेक्निक्स है उनके ड्रॉबैक्स क्या हैं और ये जो ऑप्टिकल टेक्निक्स है उनके क्या एडवांटेजेस है ओवर दिस कन्वेंशनल टेक्निक। तो सॉरी, तो पैपिस्मियर टेस्ट है, ये आपका इसका सेंसिटिविटी बहुत लो है, मीन्स ये एबनॉर्मल को ये फॉल्स नेगेटिव रिपोर्ट बहुत ज्यादा देता है, यानी वो नेगेटिव नहीं है लेकिन उसको नेगेटिव बता देता है। और स्पेसिफिसिटी हाई है, मीन्स हो सकता है कि कुछ ऐसे सैंपल भी हो जो नॉर्मल है लेकिन उन्हें एबनॉर्मल कह दे, लेकिन मेनली इसका जो लिमिटेशन है वो ये है कि एबनॉर्मल केसेस बहुत ज्यादा मिस कर जाते हैं। तो फिर आप क्या करते हो कि एचपीवी टेस्ट, कोल्पोस्कोपी और रिपीटेडली सेम सारे टेस्ट आपको रिपीट करने पड़ सकते हैं। और यूजुअली आप ये टेस्ट करते हैं, तो जैसा जिस हॉस्पिटल में मेरा ये वर्क था वो था जीएसवीएम मेडिकल कॉलेज कानपुर, तो वहां पर ये 7 से 10 दिन का ये टाइम इजीली हो जाता था पैपिस्मियर रिजल्ट आने। लेकिन यदि उसी तरह से यदि आप देखते हो कि इस पे ऑप्टिकल टेक्निक्स पे, तो इनका सेंसिटिविटी और स्पेसिफिक दोनों हाई है, तो वो या तो किसी भी सैंपल का मिस और ओवरकॉल्ड दोनों को है ना मिनिमाइज कर देता है। और आपको कोई एक्स्ट्रा टेस्ट की रिक्वायरमेंट नहीं है, लेकिन क्योंकि शुरुआत में इसको आप रिसर्च एंड डेवलपमेंट स्टेज है, R&D स्टेज है, तो आपको पैथोलॉजी का जो गोल्ड स्टैंडर्ड जो जिसे माना जा रहा है आजकल, तो इनिशियल ट्रायल्स में हम उसको फॉलो करते हैं कि यदि जो पैथोलॉजी कहता है उस रिजल्ट को फाइनल मानते हुए अपने रिजल्ट को कंपेयर करें। और at present, what we were able to do is that we were able to tell the result within a day. और बट यदि आप पैपिस्मियर के बाद में आप कॉल्पोस्कोपी डायरेक्टेड बायोप्सी करते हैं, तो कॉल्पोस्कोपी का लिमिटेशन है कि सेंसिटिविटी तो हाई है लेकिन स्पेसिफिसिटी वेरी लो है, यानी कि आप है ना बहुत सारे सैंपल ऐसे हो सकते हैं जो कि है ना नॉर्मल है लेकिन मुझे आप एबनॉर्मल बोल दो, और यदि वो एबनॉर्मल दिख रहा है तो आपको बायोप्सी करनी पड़ेगी। और ये बायोप्सी करने के बाद में सैंपल आपका पैथोलॉजी लैब में जाता है और फिर डिफरेंट टेस्ट से होते हुए आपके ये फर्स्ट टेस्ट से लेके फाइनल आपका जो रिजल्ट देखने तक करीबन 1 महीना लग जाता है, 30 से 40 दिन लग जाता है। लेकिन यदि वहीं अभी आप ऑप्टिकल टेक्निक्स के बारे में बात करेंगे, हाई सेंसिटिविटी, हाई स्पेसिफिसिटी, नो नीड ऑफ बायोप्सी, और you can real-time results you can. So looking at those advantages, different research groups are doing research on this field. यदि किसी भी PhD रिसर्च स्कॉलर या फिर MS स्टूडेंट जो रिसर्च के लिए एक इस फील्ड को अपना एक ऑप्शन देखना चाहते हैं, तो रियली इट इज अ वंडरफुल फील्ड और हाईली डिमांडिंग। बिकॉज लाइट एक ऐसी चीज है जो कि हम जब से ह्यूमन बीइंग है तब से एग्जिस्ट कर रही है, लेकिन इसके द्वारा हम जो नेचर का जो अंडरस्टैंडिंग है वो हमारा उतना उस लेवल का नहीं पहुंचा है अभी, अनफॉर्चुनेटली आई विल से। बट हम डे बाय डे वी आर ट्राइंग आवर बेस्ट टू अंडरस्टैंड दिस फेनोमेना यूजिंग लाइट। So if I want to summarize this talk, then it will be like how cancer starts in the particular case cervical cancer starts, and then how this when light interacts with tissue, then how you can extract different parameters. And if you talk about fluorescence spectroscopy, then using different mathematical tools, how can you discriminate the normal sample from different grades of the cancer just using biochemical information which is related to biochemical changes those are taking place because of the cancer. So with this I end my presentation. Thank you very much for your attention. यदि कोई क्वेश्चन है तो हम उस क्वेश्चन
Thank you, sir. You share very important hot issue regarding with human health. Thank you, sir, again. I request you, Dr.
Poddar, sir.
Head of Department of Botany, Yeshwantrao Chauhan College of Science, Karad, to deliver the vote of thanks.
Thank you, madam. It is my privilege to propose the vote of thanks for national webinar on sustainability science, a multidisciplinary approach. I would like to of today's webinar, Honorable Sri Prakash Pandran Patil, General Secretary, Sri Shivaji Education Societies, Board for Higher Education, Vidyanagar, Karat, for according the permission and for consistent support and guidance throughout the webinar. At the outset, I would like to express my profound gratitude Professor Arvind Kumar Sinha, former Vice Chancellor, Netaji Subhash University, Jamshedpur, Jharkhand, to be our chief guest of the webinar and sparing his valuable time and for highlighting the issues that we need to deliberate on during the webinar. I would like to thank speakers of today's webinar, Honorable Dr. Murumkar, Principal, Tuljaram Chaturchand College of Arts and Arts, Science and Commerce, Baramati, Pune, for sparing his valuable time and delivering an excellent talk on understanding biology by mathematical way. I am also thankful to Dr. Bharatlal Meena, Assistant Professor, Department of Physics, University of Rajasthan, Jaipur, for sparing his valuable time and very informative talk on early stage diagnosis. I am also thanks on this webinar for his consistent support and coordination of the webinar. I am also thankful to organizing secretary Dr. S. A. Kirtane, Department of Botany, for organization of this fruitful event. I would also like to thank to Mrs. PM Gadge Madam for giving introduction of today's guest speakers, Mrs. Suvarna Sawan for anchoring of today's program. At this moment, I wish to acknowledge the help rendered by Dr. J. Patil for the technical help throughout the webinar. I am also thankful to all administrative staff of the college for their efforts to organize the webinar. Last but not least, all the respected teachers, researchers, and student participants for your active participation in this webinar. One important announcement to all the participants: the feedback link is shared on the group as well as the Zoom webinar. I request all participants to submit your valuable feedback about the webinar. The e-certificate of the participation will be received within 2 days to each and every participant. So thank you once again, all the participants.
Thank you, sir. Thank you. Sinha, sir. Meena, sir. Thank you. Thank you all.
एक मिनट. Thank you very much.
बंद केला की बंद केला लॅपटॉप परत बंद केला परत बंद केला हां बंद केला